Good evening all. Welcome to ACE Engineering Academy. Guys, today AEE examination was held in the evening session, technical paper 2:30 p.m. to 5 p.m. Now I would like to discuss about the technical paper under electrical engineering. Guys, the total paper is easy to moderate and some of the questions, 10% questions are so much difficult. You need not worry about that. Now I would like to present that weightage of the today's electrical engineering paper for each and every subject. I would like to list out here. Under power electronics, out of 150 questions, 21 questions came, and electrical circuits 16 questions, analog circuits 16 questions, power system 15 questions, control systems 11 questions, transformers 8 questions, induction machines 11 questions, synchronous machines 8 questions, DC machines 8 questions, EMF electromagnetic field 9 questions, and under digital 8 questions are there, signals and system 5 questions, utilization of electrical energy 8 questions, measurement 6 questions. These are total 150 questions, sir. Guys, I can say that maximum questions we got from machines, because here I have taken that subdivision of the machines, transformer, induction machines, synchronous machines and DC machines. And the major portion or the major syllabus or the total marks under machines, more questions are covered. Those who are answered machines 100%, definitely you will get there, you will qualified. Now I would like to give that each and every subject, each and every question key as well as the explanation part, and my colleagues, my friends are there, and under all these subjects I am dealing with the electrical circuits. Let us start with the electrical circuits. First, here 16 questions are there. Guys, out of 16 questions I can say that 90%, 1 or 2 questions are so much difficult, but rest of the all questions out of 16, 14 questions you can easily answer that, because out of 150 questions which is carrying 300 marks, that means if you answer the 14 questions, 100% 14 questions, definitely you will get 28 marks. Let me take that one by one. I see this. Right, the first question. The question is, a DC voltage of 54.6 volts is applied across an electric bulb which draws 3.76 amperes current. What is the power consumed by the bulb? Guys, this is very simple. Whenever if you take that bulb, by knowing that voltage and bulb filament resistance, we are considering usually V square by R, but direct voltage and current is given. You can make it directly product of that one, you will get it. The product of the voltage and current, the power, right, power P is equal to V into I. Direct product here, it's very simple. You will get the answer as a 205.296 watts. It's very simple. Everybody will answer the question, no doubt in that. And let me take the next question. Right. What should be the value of the capacitance so that the resonant frequency of the below is 314.16 radians per second? Guys, here the resonant frequency is given 314.16. You know that pi value is equal to 3.14, no? If you multiply with 100, you will get 314.16. You should be keep in your mind. Then directly, if you do this network, this is the circuit which we can compare with here under resonance condition. This is the parallel circuit. Under parallel circuit, you will get it here. Under parallel circuit, admittance can be added. The solution for this one, total admittance I can take it YRL plus YC plus YR. This is the addition of the admittance. But guys, here he wants only the value of capacitance. That's why you need not bother about that resistive portion. Then you need to concentrate on only these two, because under resonance condition, the total admittance imaginary part we need to make it as 0. That's why we have to concentrate on this part. Once you concentrate on this part, imaginary part you will get it 1 by this is R plus JXL plus 1 by minus JXC plus 1 by R. Guys, see this, the imaginary part, suppose if you take that R minus JXL by R square plus XL square plus J by XC and 1 by R. This is R1, suppose if you take, this is R2. Guys, and see this, guys, the imaginary part you will get it, the imaginary part, take the imaginary part here you will get it, J times of that, only 1 by XC, this is the positive, and XL by R square plus XL square. Imaginary part value is equal to 0. If you do that, you will get it, the final answer here, R square plus XL square is equal to XL into XC. XL into XC is L by C, na? Yes or no? Now finally you will get the C value. If you substitute the value of here, XL value, remember that he was given that resonant frequency omega naught L. If you do this exercise, definitely you will get the value of capacitor, you will get value is C, 0.1 millifarad you will get it. C value 0.1 millifarad you will get it, right? Do the calculation, definitely you will get it. Here the final is resonant frequency is given, imaginary part is equal to 0, you will get the capacitance value. Let me consider the next one. Guys, the next question is consider the circuit below, the voltage across 3 amperes current source. Guys, this is the only one question you may feel that very much difficult, but here once you see that here the nodes, here how many nodes are there under nodal analysis. According to the question, we need to estimate that voltage across the current source V1, V2 and V3. Once you see that according to the values, here see that the branch resistance values are also not similar here. That's why this is somewhat time taking question. Better to leave this question usually whenever in the examination if you want to. Suppose if you want to solve the question at that instant, it will take so much time. It is a time killing process. Don't touch these type of questions. But here I will provide a simple solution for this one. But that one also some calculation part is required. That's why here for this one you go for that to reduce the number of unknown node voltages, star to delta conversion. If you do the star to delta conversion, definitely you will get only 2 nodes you will get it. These values, this value, this value, if you know that, the network is going to be, here the solution will be like this. I will provide that solution, you need to do that. I am not giving that entire solution. This is the way, if you do, definitely you will get the answer within 2 or 3 minutes. It will take time, no doubt in that. These type of questions, you should judge that and directly you need to go for that. These two are parallel, and this is the voltage is required. This voltage is required. If you do that, nodal analysis here, and here also we can take it under nodal analysis. See this one, you need not go for this one also. See this one here, if you do the STT source transformation technique, only 1 voltage you are having, that is our required voltage. V1 is our required value here. V1 is our required value. If you do that by KCL at V1, you will get the V1 value is equal to, even V1 value is equal to 52.35 volts. Guys, are you getting the procedure? I am giving the procedure only. I am not giving that exact solution. Definitely we will upload the exact solution. You can get it from ACE online website or ACE Engineering Academy website. Definitely you will get the total solution. Here I am providing that answer as well as how we need to do that question, right? The calculation part. The answer you will get 52.35 volts, right? Now let me consider the next question. See this, guys, this is very simple. Without putting pen, you are able to take. Think without ink. Already I have given in the class. These type of question, if you identify that, think without ink, you are able to take this. What is the Thevenin's equivalent resistance of the network? By looking into these two terminals, this is the bridge. Once you take the bridge is balanced. That's why the galvanometer branch can be neglected. How you neglect? By make the open circuit. Since the galvanometer reads current, by making the current 0 means open circuit, under that instant I can say 10 and 10 are in series, 10 and 10 are in series, both are in parallel. Finally, the answer you are getting that R in is equal to, or R Thevenin's is equal to, what we are getting that? R in value is equal to 10 ohms. It's a very simple. Here, bridge balanced condition, you have to take it. Now let me consider the next question, right? The question is, in the circuit below, the power dissipated in RL as a function of RL is schematically represented by which of the graph? Guys, this is, already we have discussed in the class, this is the maximum power transfer theorem. Under the maximum power transfer theorem condition, a source is connected or the Thevenin's equivalent is connected to the load resistance. Here load resistance is variable. Then here power dissipated in the load and load resistance. How it is? Power is a non-linear. You know that power is non-linear across the resistor. That's why once you recall that, the power versus load curve, already I have given that, which is a bell curve, whatever the curve here, power versus load curve. Under maximum power transfer theorem, I have given that load versus or power versus load curve. How the curve? It is the bell curve. We are getting that bell curve. Up to RL is equal to RS, this one. This is the P maximum we are getting. How the given options, according to the given options, as per the obtained response of power, which is coinciding. Which one is the coinciding? According to this, I can say that option fourth one, D is the correct one, right? Directly you can take it. You need not go for any calculation, right? The next one is a balanced three-phase supply feeds power to a balanced three-phase RL load. Under this condition, the total instantaneous power supplied to the load would be A, pulsating with non-zero average, B, or the second option 0, and the third option is a constant, and the fourth option is pulsating with 0 average. Guys, this question is the one of the previous PSUs, public sector units, it was given. Those who are having idea regarding that, definitely you can answer that. And the explanation part for this one, the answer is, some of the students are, they are eagerly about that answers only. That's why I am giving the answer first, then I am explaining that. Now it is a constant. Suppose if we take that the three-phase balanced supply, V of VA, VB, VC, nothing but Vm sin omega t, Vm sin omega t minus 120, Vm sin omega t plus 120. If you consider that the load as RL, Z at an angle phi, lagging power factor load, you need to estimate that instantaneous power across each and every phase, nothing but PA, PB, PC. If you add all these, final power you will get it. This is the solution. I can give that. VA, VB and VC with this ZL is equal to Z at an angle phi, lagging power factor. with that IA, comma IB and IC, you will get it. Finally, the total power, instantaneous power, you will get it. What? VA is equal to VM sin omega t. If you do like that, the final value you will get it 3 times of Vm Im by 2 cos phi. Rest of the terms will be cancelled. According to that, Vm sin omega t into Im sin omega t minus phi, like that you will get it. Rest of all the terms will be cancelled. This value is constant. This is constant. It is not time varying function. It is not a time varying function. 3 times of the average power you will get it. Vm Im by 2 into cos phi watts you will get it. Is it right? You can also see that by taking this here, the value of Ia is equal to what? Ia is equal to Va by ZL. It is a constant load here we are considering. Like that IB is equal to. But here you need to be considered under 3-phase supply, Va, Vb, Vc are displaced from each other is equal to 120 degrees, right? The answer is constant, right? Now let me consider the next example. Guys, this is under 2-port network parameters, right? A 2-port network has a following impedance in all ohms. Ohms are given and the input is connected to a sinusoidal voltage source Vs having 50 ohms of series resistance. A 1 kilo ohms load resistor is connected. Calculate the voltage gain of the network. This is very important here, voltage gain of the network. Now, I will give that the solution for this. Once you see the network, how you are considering, definitely you can get it. This is the network, which is the 2-port network and input, and this is the output. Now this is V1, this is V2, getting I1 and I2, and what he wants to take that, he was given that input as a 1 voltage source with a series resistance. This is the data provided as Vs with 50 ohms, no? Yes, with 50 ohms. And V2 output is connected with the what? 1 kilo ohms resistance. 1 kilo ohms. This is the network here. What voltage gain of the network? He was given that voltage gain of the network means what? Voltage gain of the network. Gain means you know that it is V2 by V1, right? Now, according to that, he was provided the what? Impedance parameters are given. V1 is equal to, what I can take it? Parameters. Z11 10 square into I1 plus 1 into I2. Like that, V2 is equal to minus 10 power 5 into I1 plus 10 cube into I2. These are the equations are given. And finally, what we need to get it? V2 by V1. Guys, V2 by V1, if you want to take it, the ratio of V2 by V1, we should express I1 in terms of I2 or I2 in terms of I1. That value you will get it. For that, he was given this data. He was connected with 1 kilo ohm output. Then I am able to express V2 value. Can you define that V2 value here? Yes, I can define V2 is equal to minus I2 times of 1 kilo ohms. If you take that V2 value is equal to minus I2 times of 1 kilo ohms, the second expression, you will get that relation between I1 and I2. By using that, you are able to get it that V2 by V1, this is the gain. Are you getting my point? First take V2 value in the second expression. This get the relation between that I1 and I2. Take that in the first and second expression, get the ratio between V2 and V1, which we will get it, GV value, he was given that minus 1000 by 3 you will get it. This is the answer for this one, minus 1000 by 3 you will get it. Is it right? It's a very simple, but it is time taking, no doubt in that, right? Now the next question, see the next question, it's a very simple here, without calculation you are able to take it. See this, the question is, consider a circuit below with DC supply Vs as 5 volts, the series resistance Rs is equal to 5 ohms is connected as shown, maximum power dissipated through RL. Guys, before going to that first here, you know that under maximum power transfer theorem, two conditions you need to be applied. First one is load is variable or not? Yes. Second one, across the load circuit, entire network is the Thevenin's equivalent or not? Yes. That's why I can take it, this is the DC, the total value P maximum, the solution for this one directly I can take it here. V square by 4RL you can take it, V square nothing but what, 5 square by 4 into RL, 25 by 20 here, 25 by 20 means what, 5 by 4, 1.25 directly I can take the answer as option 1. You need not go for any calculations, right? This is very simple here. That's why the P maximum standard formula which we have taken in the class, V Thevenin square by 4 times of R Thevenin's, which is 5 square by 4 into 5, which is 1.25 watts. Very simple, right? Now let me take the next one. Right. 4 microamperes current flows through a conductor for 4 seconds. Find the number of electrons passed through a conductor. It's a very simple. The basic question here, I can say that it is the +2 question. Now, how you have to take that? According to that, number of electrons you need to take it that. Number of electrons means you know that the charge is required Q equal to what? I into T. Or otherwise, current you know na, dq by dt. Na? According to that, you can define this one. And Q equal to what? N into E. Na? See this, directly I can take it. Here N value is required, I value how much given? 4 micro, 4 into 10 power minus 6 into time, 4 second is given, and electron E 1.6 into 10 power minus 19. Then finally you are getting that what? 1 into E power means 10 power you can take it, 10 power 14 you will get it, that actually has to provide that E power 14. 10 power 14 you will get it that 10 power 14 electrons, 10 power 14 electrons are required. That's why option A is the correct one or 1 is the correct one, right? These are the very basic questions. Now the next one, let me consider the next one, right? This is somewhat you may feel some difficult regarding these transient circuits. Consider a series RLs shown below. U of t and ut minus t naught are unit step functions. The current flowing through the resistor or at time t greater than 0 is given by. Guys, you may feel that once you are familiar with the signals and systems, definitely you are able to take that the resultant of the excitation, this part is very important here. Once if you are able to identify that, definitely you will get the answer. Now, I will try to take this direct answer how you have to do it according to the given options. See the options, these are the options are provided. Based on the options, I will provide directly how we need to take the solution and detailed solution we will upload, right? Because all the subjects we need to be discussed. That's why I am giving that solution key as well as the easy solution or direct solution. Now see this one. The solution here u of t, I have to take that v naught into u of t minus v naught into u of t minus t naught. Guys, see this, I want to consider that the input, how the input we are getting that and how the output may be. The input will be, the input he was given, first one is what? First one I can say that u of t, this is the v naught and minus t minus t of t, that is I can take it, t minus t naught t means it will start at t naught, because it is a minus, we will consider it will start here with the same minus V naught, and the resultant value you are getting that, the resultant will be pulse up to 0 to T naught as a V naught magnitude. How the response for this one? The response might be like this. This is the response, you can take it. For this response, how you are getting the solution for this one? Here, this is the charging expression, and this is the discharging expression. This is the charging expression, this is the discharging expression. Guys, if you see the options, based on these options here, I can say that here, the first two, you will not get the internal is here T. Here T naught you will not get it here. First and second options you can eliminate. By taking the eliminating process, first T naught value you will not get outside, definitely. That's why 1 and 2 you can eliminate. While coming to the 3 and 4, definitely whether it is positive or negative. According to that, see this one, as per this, the signal while the inductor is charging from 0 to T naught, you will get that in the expression exponential T minus T naught you will get it. That's why here, once you see that the solution for this one, the third one, internal or once you multiply with this, I would like to consider that third one and the fourth one, the third one and the fourth one, see this, third one and fourth one. Based on this, I can define the current passing through that I of t is equal to V by R e to the power minus R by L into T e power R by L into T naught minus 1. Guys, once you see that here, right, V by R into e power minus R by L into T minus T naught minus V by R into e to the power R by L into T naught. Guys, see this, these two, according to that expression or according to the response what we got for the current, this blue line is current response. Blue line is what? I of t, current response which is passing through the resistor as per the question. As per the question, current flowing through the resistor and inductor is same. Actually, this is the inductor current which is same as resistance current. Now, I can take it according to this one T minus T naught we are getting. In the fourth one, if you say that here, the fourth one, I of t value V by R into e to the power, once you multiply R by L into T plus T naught, you are getting that, and minus V by R into e power minus R by L into T. That's why once you see that these two, definitely I can say that which one is the correct one. This one is the correct one, this is not correct, because in this term T plus T naught, you may not get it. That's why here we can take that option 3 is the correct one. Option 3 is the correct one. Guys, we will provide the solution for this one in terms of Laplace domain. Suppose whenever the special functions, I have already discussed in the class, if the special functions are given as excitations, definitely we need to take as a what? We need to take a Laplace transformation. By doing the Laplace transformation also, you will get the same result. That solution we will upload in the website. Okay. Now let me consider the next one. See this. Which one of the following represent an expression for damping factor of RLC series circuit? Guys, for RLC series circuit, this is also very simple here. Damping factor is equal to zeta is equal to damping factor zeta is equal to what we can take it? Zeta is equal to under networks 1 by 2 Q here. Already I have given this. Q factor for RLC series circuit is what? Q factor is equal to 1 by R under root L by C. Then finally for series circuit damping factor, this is the damping factor. Under damping factor, what we are getting that? If you substitute here in the damping factor Q value R by 2 times of under root C by L. Is the option is given? Yes. R by 2 times of under root C by L. The option is given as a third option. Okay. And it's a very simple question. You can easily attempt that. Now next one is, see that initially the switch is closed and steady state has been reached. At t equal to 0, the switch is opened. What is the voltage across the capacitor at t equal to 0 plus? Guys, this is also very simple. Once you see that, under transient circuit analysis, I have provided the easy solution or without taking calculations also. If you want to get it that at t equal to 0 plus value for an inductor or capacitor, you need to take that. That value is initial value, can be considered the history value. History value, if you want to get it that is always before t equal to 0. Before t equal to 0, where you have to take it? At t equal to 0 minus. At t equal to 0 minus what state? It is a steady state. Now take that before t equal to 0 switch position. Yes, switch is closed. Nothing but across these 2 points, 60 volts is there. Now under steady state, how the capacitor is open circuit. Under that instant, resistor and 5R both are connected in series. Then which voltage we need to take it? Vc of 0 minus. That voltage is what? Voltage across 5R. How you are getting? By VDR, total voltage 60 into that resistor by sum of the 2 resistors. 60 into 5R by 5R plus R, how much? 6R. 5 by 6 times of 60 is what? 50. That is what? Vc of 0 minus is same as Vc of 0 plus. Since across capacitor, voltage doesn't change instantaneously. Energy does not change instantaneously. That's why with this directly I can take which is the correct option. Option 4 is the correct one. I need not go for any calculation for this. Haven't you taken any calculation? No. Right? This is the way how you can do that without taking any calculation part. Detailed solution we will provide in the website. You can access from the website, right? Now the next questions. See this. Consider a circuit below with Rp is equal to 5 ohms. Its equivalent which one of the following? See this. 5 amperes current source is, this is very simple here. He was provided all the voltages. Current source transformation by using STT here. I can say that by source transformation technique, by STT, voltage value how much? V is equal to I into R, 5 into 5, how much here? 25 volts. Yes or no? Then definitely I can say that here 25 volts with RS2 is equal to what? Same resistor can be connected. It should be connected the same resistance. That's why fourth one is the correct one. It's a very simple here, right? Now the next one. See this, which of the following transformation between jet impedance and hybrid parameters is correct? Guys, for these type of questions you may get a doubt, sir, this much of complicated question. This is not complicated here. You should remember only the expressions under two-port network parameters. See this, within 1 minute how I am going to do the solution for this one. The solution for this here, H parameter should be expressed in terms of the hybrid parameters. First list out the jet parameters. How you take that? V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. Now list out the hybrid parameters, H parameters. H parameters is what? V1 is equal to H11 I1 plus H12 V2 because V1 I2 are the dependent variables. I1, V2 are the independent variables now under hybrid parameters. This is very simple here. Only one value you have to be considered. We should express Z parameters in terms of the hybrid parameters. See this, how I am doing. Take that Z parameter. Z11 is equal to what? V1 by I1. This is the only calculation you have to do it. I2 is equal to 0 here. Very simple. See this one, when I2 is equal to 0 here, see this one, when I2 is equal to 0, we are getting from the hybrid parameters I1 V2 relation. Now, when I2 is equal to 0, from this I can take it, V2 is equal to, because we need to go for that V1 and I1, V2 value how much? V2 is equal to minus H1 to H21 by minus, you should be careful regarding this, subscripts are very important here, H21 by H22 I1. Are you getting? Now take the first expression. From the first expression, you will get V1 by I1 by replacing V2 is equal to minus H21 by H22 by taking that. See this one? Now from the first expression, here V1 is equal to H11 I1 minus H21 and H12 by H22 into I1, right. Now see this, here V1 by I1, both I can take it common, V1 by I1 which is Z11, what we are getting? H11 H22 minus H21 H12 by H22, are you getting? This is the ohms. Once you take this, here this value for all the options are same. All the options are same is there. That's why we should take that next one. When I2 is equal to 0, here what we have to take it, one more parameter, one more element you will get at H21. V2 by I1, na? See this, from this V2 by I1 we are getting, na? What it is? V2 by I1 value. If you eliminate, see this one, V2 by I1 value, what we are getting? Directly you will get it, V2 by I1 value is equal to minus H21 by H22, which is equal to what? Z21. See this one, where it is? Minus H2 by H21 by H22. It is having in the first option, minus H21 by H22. But here one more value we need to be considered. Here what value? When I1 is equal to 0, when I1 is equal to 0, we should get it that. See this, when I1 is equal to 0, what we are getting? V1 is equal to Z1 to I2. In this one, I1 is equal to 0. V1 value what we are getting? When, see this one, when I1 is equal to 0. Two values you are getting, H1 to Z12 is equal to V1 by I2 here. From the H parameter, see this, what value you have to get it? V1 by I2. V1 by I2 is what? V1 by I2 you have to take it when I1 is equal to 0. With this we are getting V1 by I2 value, we can get it directly, H12 by H22 plus H1 by H22 we are getting that, H12 by H22. This one positive value you are getting. We are not getting the negative value. We are not getting the negative value. We are getting that positive value. What it is? V1 by I2 when I1 is equal to 0. Once you divide with this, H12 by H22. But in this one, negative sign is there. In this one, no negative sign. That's why with this, I will take it option. Which one? Third one is the correct one. This value we can take it H12 by H22. And finally, H22 you will get 1 by H22. Z22 value is equal to 1 by H22. This is the way how we can take it, right? Now, the next one, see this one. This is very simple here. The resonant frequency omega naught for RLC parallel circuit. Very simple. You know that? Option 1 is the correct one. You need not go for any calculations. Very simple one, resonant frequency. And the output of the circuit is taken across the resistance. The bandwidth of the circuit will be. Guys, in this example, you may have a doubt regarding this. Sir, output you want to be considered. Where you want to be considered? Output you want to be considered across resistor. If you take across resistor, then what we are getting that? We are getting it is what? Band pass filter. Under band pass filter, you know that the same relation, whatever we are getting that, the current expression, what was the current expression? The current expression, current versus frequency, you will get that. What bell curve we are getting now? This is the band pass filter, F1 to F2. That's why I am giving this stuff or this information for this one. he wants to take the bandwidth of the circuit. This is RLC series circuit. The bandwidth of the circuit, Q factor, using the Q factor you can take it from this bandwidth is equal to resonant frequency by Q factor, because in terms of radians is given. That's why I should consider that omega naught. Q factor for RLC series circuit is what? Omega naught L by R. That's why I can take the bandwidth direct formula R by L. Resistance value how much given? 100 ohms given. And inductance value 0.1 given. Nothing but bandwidth how much you are getting? 1000 radians or 1K. 1000 radians or 1K. Which is the correct option? The correct option is what it is? 1K radians, right? Bandwidth. In terms of radians, he was given that. That's why 1 kilo radians. Right. These are the questions under electrical circuits or network theory under networks given. Guys, I hope you got the clarity regarding each and every question. Even though if you are not having any clarity, within few days or tomorrow or day after tomorrow, we are going to upload the detailed solution in our website. You can access, and any issues or any doubts you are having, you can easily contact to our people. Okay. Thank you very much, and I would like to hand over this to electrical machines by Basha sir. Please come, Basha sir. Thank you. Thank you very much.
Good evening all of you. So I hope everyone did your best level in the examination. So let's verify your answers from electrical machines. So I said already many times in class also, majority of questions will be from machines, and the most easiest subject is what? Machines. Now just verify your answers for each topic one by one. Let's see for transformers first. So overall from total 4 parts of machine, I observed that from induction machine we have little more, and total questions from machines is around 35 we got approximately. And out of this, definitely just by listening class you can answer around 32 questions. So only 2-3 questions, little calculation, little concentration required to answer. Okay, let's see the first question. In a single phase transformer supplied from constant input voltage, the magnitude of load current is kept constant while the power factor is varied here. Under this condition, the maximum efficiency occurs at unity power factor, or at which power factor we get maximum efficiency simply. So first of all, if you remember from class, at which condition we get maximum efficiency? 2 conditions. So one condition with respect to current variation. So at which current, that is fraction of load, we calculated X, now it is. What is that X formula? Square root iron loss by full load copper loss. And another condition is UPF condition. So efficiency is maximum at UPF always. So from the given options, directly option 1, the maximum efficiency occurs at unity power factor is right. Okay, next question. In a transformer, the load current is kept constant and power factor is varied. Under this situation, zero regulation will be observed at dash. So where we get zero regulation? So zero regulation always possible at leading power factor. That may be transformer, that may be alternators, anything. So direct question it is at leading power factor. Okay, next. Which of the following statements is entirely true regarding eddy current? So there are 2 questions based on eddy currents in this paper. Let's see here. Which of the following statements is true? So eddy current loss can be minimized by thin laminated core. So this is right or wrong? Yes. So we can reduce by thin laminations, okay, compared to thick laminations. And eddy current is proportional to flux frequency. Yes. Current always depends on magnitude of flux in the core, and whatever the flux frequency is there, same frequency for current also. So it depends on flux frequency itself, and if you see remaining, they are not correct. Okay, first option is correct for this question. Okay, next question. The maximum efficiency of a single phase transformer operating at UPF is found to be 90% under full load condition. Maximum efficiency is 90% at full load. Next, what is the efficiency at half full load at same power factor? If you remember the efficiency curve, we get approximately like this. Efficiency versus load current variation. So it is in this way. This is the full load. The full load efficiency is given here. How much it is? 90%. And approximately at half full load also we have same efficiency. Why? Because if you observe from options, so all these options are below 90. So which option, how can we say? So it is not possible. No? That's why we have to consider at half full load also it is almost 90% only. So option 2 is correct. Okay, next. If P and pH are the eddy current loss and hysteresis loss, generally we represent WHW, but here given some other notations anyhow. In a magnetic core operating with alternating flux density waveform, then which option is correct? So here it is not mentioned clearly whether the density is constant or variable. So let us consider constant only, because they mention only alternating flux density here. Generally we operate at case 1 only. Now hysteresis loss proportional to frequency and eddy current loss proportional to frequency square. Now they are asking here the sequence is eddy current loss and hysteresis loss, PE and pH. PE proportional to frequency square and pH proportional to frequency. So option 4 is correct for this. Okay, next question. So this is directly from conditions. For the parallel operation of 2 transformers with the same voltage ratio and different kVA ratings. kVA rating may be different always. The load shared by these transformers in proportion to their kVA rating when the transformers have dash. So I think question you understand well. How these two transformers will share the load. So that we need to get by satisfying one of the condition. Which condition it is? Ohmic condition or impedance condition. If impedance given in ohms, it should be inversely proportional to kVA rating. And if it is given in per unit, the two transformers should have same per unit impedance based on their respective rating itself. So from given options, equal per unit impedance on their ratings. Next. Which of the following is a characteristics of ideal transformer? Maybe here you got little confused. Whatever we discuss generally in ideal characteristics, that is not there directly here. But if you observe infinite core reluctance, this is wrong. So ideal case, what is the reluctance should be? 0. Next, 0 stored magnetic energy and large magnetizing current. Generally, practically magnetizing current is very small. So large means it is not ideal case. And 0 core flux, because this is also wrong. Ideal case, there should be some residual flux. Even there is no current, some flux will be there. So this is wrong. So 0 stored magnetic energy is correct. What is the meaning of this is, generally some energy will be stored in materials in the form of energy loss we treat it is. But no loss here, no energy stored. Whatever we supplied input, same will come output, no losses. No. That's why no energy stored in the core. So this one is right. Next, which of the following is correct regarding eddy currents in the coil? Eddy currents in coil. So read the options first. By making use of laminated core, eddy currents are increased. So with laminated core, eddy currents decrease. So this is wrong. Eddy currents converts useful energy into heat and waste it. So what is the eddy current loss? Our eddy currents will develop in a core, that is in the form of loss will be there, heat will develop, and that is just wasted. We are not using that one. That's why this is okay. And if you see remaining, eddy currents flow in straight line. This is wrong. Eddy currents flow is always circular only. So we have seen already, eddy currents will produce a flux which is opposite to main flux, which is the cost to produce eddy currents. So this is not straight line. Eddy currents helps in generating electrical energy, but we are not using it. That is waste. That's why option 2 is correct. So these are the questions from transformer. Let's see the next topic from DC machines. Okay, let's see from DC machines the questions we got. See the first question. A DC shunt motor with an armature resistance of 0.15 ohm is supplied from 230 volt input supply. Okay. If the back EMF of motor is 200 volts, then the armature current will be dash. So this is direct question, directly from KVL of this. See this. So what is armature current? V minus EV by RA, direct substitution it is. So what is the supply voltage? 230 volt, and back EMF given is 200, and armature resistance given 0.15. So this is 230 minus 200, 30 by 0.15. How much it is? This is we get 200 amperes. Calculate this 200 amps. Option 4 is correct. So direct calculation from equation. Next. Consider the following list regarding speed control of DC motors. So many times I said from speed control methods, that may be DC motor, that may be induction motor, definitely we can get questions. Okay. So very easy one. Armature voltage control. So armature voltage control or voltage control will give below rated speed or below base speed it is. So A satisfying with the 2. Next, field current control or flux control method simply. So flux control will give above rated speed always or high speeds. So speeds above base speed. So A2, B3. A2, B3, there are two options here. Okay. Now we have to confirm from C and D. Let us take C. Use of diverter resistor. In which motor we use diverter? For series motor we use, no? So one of the flux control method for series motor is diverter control. So diverter control we use for series motor, C for 4. So C for 4 is option 3 it is. So directly we can put. Okay. So option 3 correct for this. Next question. Consider the following statements about DC series motor. First, read the first statement. The developed torque in machine is directly proportional to current. So in a series motor, torque proportional to square of the current. But it is given only directly proportional to current. So that is wrong. Next, the motor is suitable only for loads having small starting torque. Particularly series motor we use for very high starting torque. But they given very small starting torque. So this is wrong. First also wrong. And third one is, the machine can run even when a single phase AC supply. That is only universal motor, no? So which works for both DC supply and AC supply. So that is correct only. Now which of the above statements are correct here? Only C correct. So that is option 2 is right. Okay. Next question. Which of the following statements is true in case of dynamic braking of separately excited DC motor? So in dynamic braking, first what we do? So in dynamic braking, we will remove supply to armature always, and across that armature we connect a resistor. So that is dynamic braking procedure. Procedure is important. Now read here. The voltage supply is removed and armature is connected across a resistor. So directly option 1 is right. So no need to go to other options also. Next. Consider the following statement about armature MMF in a DC machine. What is the shape of armature MMF? So we have shape of armature MMF, armature flux. Armature MMF is triangular shape, but armature flux is saddle shape. So MMF is triangular. Shape of armature MMF is triangular shape. So this is B statement is right. And the MMF wave rotates with respect to armature. I given some questions there. What is the speed of armature flux with respect to stator? Armature flux with respect to rotor, like that. So armature MMF nothing but you can consider armature flux. What is the speed of armature flux? Stationary with respect to stator, but rotating with respect to armature it is. So it rotates with respect to armature. So this is also right. Now if you see remaining, it is not correct. This is rotating with respect to stator, wrong it is. So BC, only BC means option 1 is right. Okay, next question. A DC shunt motor supplied from 220 volts and running at 1200 RPM. Now the supply voltage reduces to 175 volts. What is the speed of motor? So many times I said in the speed control, voltage control not suitable for shunt motor. So even if you reduce voltage, the speed will be almost remain same, no change. So this is 1200, now also 1200. Okay, first option is right. Next. A 200 volt, 1200 RPM, 100 ampere DC separately excited motor has armature resistance 0.1. It is braked by plugging. Plugging method is used. From initial speed of 1200 RPM, what is the external resistance to be placed in series with armature to limit braking current to twice full load value? So in the plugging method, what is armature current equation? Plugging. So armature current IA equal to V plus EB divided by RA plus RB. But how much current we have to limit? Twice we have to limit. That's why 2 IA I will take. And here if you substitute 2 into, what is the full load current given? 100 amperes. That is only armature current here. Supply voltage is 200 volts. And you calculate back EMF, which is V minus IRA under normal running condition. 200 minus 100 into 0.1, you will get it is 190 volts. Divided by RA is 0.1 plus RB. Now if you find the value of RB, we will get 1.85. But if you observe from options, there is no 1.85. I think by mistake they given 1.5 instead of 1.85. So here 1.85 should be there. Okay, so correct this question. Next. If the magnetic circuit in a DC machine is operating under saturated conditions, then the armature reaction in the machine results in dash. Now, due to armature reaction, one of the effect is what? Demagnetizing effect. Means the flux in the machine gets reduced. The flux in the machine reduces. But if you see the options here, results in decrease in the value of flux per pole, increase or decrease depends on generator or motor, increase in value of flux, no change in flux. So due to armature reaction, definitely the flux per pole little bit reduced, some 2%, 1%, 3% flux will reduce. So that may be generator or motor, anything. That's why decrease in the value of flux per pole is correct. Okay, next. So these are the questions from DC machines. Let's see some questions which are given from induction machines. Let's see the questions from induction machine. So in this topic we have little more number of questions with a little concentration required to answer this type of question. Some 2-3 questions are there in induction machine like this. See this. What is the condition to achieve regenerating braking of induction motor? Regenerative braking. So this regenerative braking will take place whenever the speed of induction motor become greater than synchronous speed. Okay. Generally induction motor rotates below synchronous speed. But if the speed becomes more than synchronous speed, this regenerative braking will be taking place. So which option is right? See here, will be takes place whenever synchronous speed should be a little lower than rotor speed. So this is rotor speed. Rotor speed is greater than synchronous speed, or synchronous speed is little less than rotor speed. Option 4 is correct for this. Okay, next. A constant V by F controlled induction motor is fed from variable voltage, variable frequency source, voltage source inverter. The motor is operated within the base speed, means with below rated speed. Which of the following is true in torque speed characteristic of this motor? So if you want to operate the speed below rated, what we have to do? We have to reduce not only frequency but also voltage, that is V by F control. Both voltage and frequency we have to reduce, such that V by F equal to constant for below rated speed or below base speed it is. Okay. Now whenever V by F is constant, what is the relation of starting torque, maximum torque? So they are asking here about starting torque what happened, maximum torque what happened. Okay. Now we know that from starting torque equation, it is proportional to 1 by F into V1 by F whole square, and maximum torque is proportional to V1 by F whole square. So these equations you should remember from torque equations. Now whenever V1 by F is constant, like that we are varying both voltage and frequency. So when V by F is constant, what we are doing? In order to get below rated, frequency decreased. As frequency decreased, starting torque increased. But from this, as both are reducing simultaneously, V by F ratio constant, so maximum torque remains same, no change in this. But only here starting torque increase. So check which option is right. Starting torque increases with a decrease in frequency, okay, and maximum torque remains same, remain unchanged, means remains same it is. So option 3 is correct for this. Clear? Next question. The speed of induction motor is increased by increasing frequency by 20%. Okay, frequency control used, 20% frequency increased. If the magnetizing current of the machine is to remain constant, then what must be done? Okay, so when magnetizing current is constant, magnetizing current of the machine is to remain constant. So when magnetizing current will be constant? Magnetizing current will be constant whenever flux density is constant. Flux density proportional to V1 by F ratio. So here how much given? Frequency is increased by 20%. Frequency increased by 20%. In order to have constant flux density, the voltage should also increase by 20%. So that magnetizing current, just like transformer it is, okay, magnetizing current remains same here. So what we have to do? The supply voltage should be increased by 20%. Supply voltage must be increased by 20%. Option 3 is correct. Okay, next question. Reducing the speed in a three-phase induction motor by stator voltage control, while supplying a constant torque load would result in dash. If you remember in voltage control method, whenever we reduce voltage, speed will reduce, but at the same time, current drawn by motor will increase. If voltage is reducing, speed also reduce at the same time. To maintain the torque constant, current will increase. So whenever current is increasing, what happen automatically? Losses will increase. So it will reduce the efficiency. Option 2 is correct. Next. The stator of three-phase 4-pole squirrel cage induction motor is rated at 1450 RPM at 50 Hz. It is rewound for 6 poles. Previously how many poles? 4 pole. So 4 pole means synchronous speed 1500. So it is rotating near to synchronous speed always, 1450 it is rotating. But now the stator is rewound for 6 poles here, and without any change made on the rotor. So no need to make any change, because squirrel cage rotor advantage is that if you change stator poles enough, automatically rotor poles will change accordingly. Okay. Now it is 6 poles. What is the synchronous speed for 6 pole? 120 F by B, 1000 RPM we get. Now this motor would dash. At what speed it will rotate? So from the given option, it will operate with a speed slightly below 1000 RPM, slightly below, near to synchronous speed. So option 3 is correct. Next one. A three-phase induction motor rated at 15 HP. So this is the question out of, I think, total machines, little calculation required. Without calculator it is difficult little bit. Observe here. It is 15 HP. So this 15 HP is the output power given, 440 volt, efficiency given 85%, and operates at a power factor of 0.9. So while delivering rated output power, rated means full load output. Next, what would be the reactive power drawn by motor under this condition? So for this you have to find first how much input power motor is drawing. So once you know active power, that input power means active power, if you know first, then automatically reactive power will come. So what is that? How to find? So we know that efficiency equal to output by input. Now efficiency given 0.85, output is 15 HP, 15 into 746 watts divided by input power. So calculate from this input power we get around some 13 point some kilowatts, 16 kilowatts something we get. Check it is. This is input power. So once you know this much input power, active power it is. This is active power. Now what is the reactive power relation with active power? The reactive power Q equal to P tan phi directly. P tan phi. Cos phi is there 0.9. So you can find tan phi from there. So calculate this. So approximately you get some 6.38 kVAr. Okay. Check this value. Calculate this. P is this active power from efficiency, and reactive power using this equation. Tan phi from cos phi you will get. Okay. So around 6.38, option 4 will be correct for this. Next. So what is the way of imparting braking action of three-phase induction motor in plugging? How to apply plugging in three-phase induction motor? So in DC motors, generally we use plugging by reversing armature terminals. Now what we have to do for this? So in three-phase induction motor, we have to reverse the phase sequence of the supply. Suppose RYB given, now change the sequence of supply to RBY. That is option 1 is right for this. Okay. Next. What is the status of machine flux for the range of frequency above rated? Means frequency increased. Rated frequency in the case of a speed regulated V by F controlled induction motor drive. So V by F drive, even it is V by F drive, what we are doing here? Frequency is increased. Whenever we are increasing frequency, flux density will be reduced. So then you no need to increase voltage, and we should not increase also practically due to insulation problems. Only frequency reduced. As only frequency reduced, density, as only frequency increases, flux density reduces. But don't increase voltage here. Even it is V by F drive, we should not increase voltage. Okay? Only frequency increased. But whenever we decrease frequency, then you should reduce voltage, so that saturation should not take place. But here we don't increase the voltage, so flux density decrease. Flux density decrease means flux in the machine decrease. Okay, directly related it is. So what happens to status of machine flux means the machine flux decreases from the rated flux. Option 4 is correct. Okay. Next. At low values of operating slip, the torque developed in three-phase induction motor is dash. So what is the relation? Everything from torque equations. For low values of slip, torque always proportional to slip. But for high values of slip, torque is inversely proportional to slip, unstable operation. So right now they are asking for low values, torque is directly proportional to slip, that is linearly proportional to slip. Third option is right. Next. So easy question, but you should get idea here. See this. A three-phase induction motor with 6 pole is rotating at 1200 RPM. Okay. The speed of rotation in electrical and mechanical radians per second respectively dash. This is in RPM. First, what is the speed equation in radians per second? Omega it is. This is mechanical. Mechanical speed is 2 pi n by 60. 2 pi speed is given 1200 by 60. So if you solve, we get it is 40 pi. Now this is radians per second, but in what it is? Mechanical it is. This is omega mechanical. Mechanical na speed, radians per second. And also we need to find electrical. How to find omega electrical? Relation you know very well. What is electrical angle always? P by 2 times of mechanical. No? Same relation valid here. P by 2 into omega mechanical. What is P? Number of poles given 6 divided by 2. Omega mechanical is 40 pi. So if you solve this, we get 120 pi it is. So this is 120 pi. Okay. And important here is you should not say again 40 pi, 120 pi. Fourth option also wrong. Why? Because they are asking electrical first and then mechanical. So electrical is 120 pi and mechanical is 40 pi. So 120, 40 sequence. Third option is right here. Option 3 is correct. Next. In rotor resistance control of induction motor, which one of the following is true with increase in rotor resistance? So if rotor resistance increases, we know that starting torque proportional to rotor resistance, and they are asking about slip also at maximum torque and maximum torque. What is the maximum at the maximum torque? What is the slip corresponding to maximum torque is R2 divided by X2, and maximum torque is independent of rotor resistance. It doesn't depends on rotor resistance. It remains same even R2 changes. So what happened? Increase in rotor resistance given. So starting torque increases. As R2 increase, slip corresponding to maximum torque increase. So starting torque increase, corresponding slip to maximum torque increase, but maximum torque remains same. So everything from equations, just read the options now. Maximum torque increases. So maximum torque increase, wrong. Maximum torque remain unchanged. Starting torque decrease, wrong. Maximum torque increases, starting torque increases, this is wrong. Maximum torque remain unchanged, starting torque increase, and the slip at which maximum torque occurs also increase. So option 2 is correct. Okay. So these are the questions from induction machines. So let's see finally what are the questions we got from synchronous. Let's see the question from synchronous machine. First one, two synchronous generator G1 and G2 rated 200 megawatts and 400 megawatts. Their full load capacities it is operating in parallel to supply a total load of 300 megawatts. Okay. If the governors in both machines are set to have a droop of 4%, what would be individual power supplied by each generator? Okay. Generally this type of question we have to solve with the triangles and all. But right now here advantage is both are having same droop here. That's why directly you can solve this without any figures and all, any calculation. See here. So their full load capacity is 200, 400 operating in parallel. So if you add both, totally how much we can supply? 600 we can supply. So at 600 it will supply 200, it will supply 400. But right now how much load is there? Only 300 megawatts load is there. So as it is half directly, it will supply 100, it will supply 200. So no need any calculation, just by observing the options you can answer this. Okay, so first option is right. Next, in an alternator, a field current of 20 amperes results an armature current of 400 amps. Okay, when the terminals are shorted, under short circuit condition it is. Next, the same field current also creates a terminal voltage of 2000 volts in open circuit. Okay, and what would be the magnitude of internal voltage drop within the machine at a current of 200 amps? Generally what is voltage drop? Voltage drop, nothing but impedance drop, IA ZS. IA is given 200. Now ZS we have to calculate. So what is the formula for ZS? Synchronous impedance, open circuit voltage divided by short circuit current for the same value of field current. So anyhow field current same they mention. But here it is not clearly given like voltage is phase voltage or line voltage. Generally from readings we get line voltage. If it is delta connected we can take directly phase. If it is star connected we take by root 3 it is. But right now here you assume phase values only, all are this. Then open circuit voltage is 2000, open circuit 2000, and current under short circuit is 400 amperes. Then how much it is? 5 ohms it is. This is impedance 5 ohms per phase. Now substitute here. So at 200 amps only we have to calculate. 200 into 5, nothing but 1000 it is. So this is the voltage drop, 1000 volts. Option 2 is correct. Okay, next question. Consider the following statements made about short pitched winding in AC machines. So why we use short pitch? To eliminate harmonics. Okay, so read the statements first. Short pitch winding results in reduced fundamental EMF. Is this right or wrong? Yes, right only. Advantage of short pitch is harmonics will be eliminated, but magnitude of that fundamental voltage will reduce little bit compared to full pitch case. So this is right. So short pitch winding increases harmonic voltages in the induced EMF. No, this is wrong. We used to reduce harmonics first. Okay. Next, short pitched coils have smaller length of overhang. So this is advantage only, no? So when we short pitch, little length will reduce there. So copper wire will reduce. So this is correct. So A and C. Which of these correct is A, C? Option 3 is right. Next. Which of the following is the reason behind inability of ideal synchronous motor to develop any starting torque? So we know very well synchronous motor starting torque is 0. It is unable to start. What is the reason for this? So from the options you can observe. Fourth option, the relative velocity between stator and rotor MMF is large. At the time of starting, when we give supply to stator, RMF will produce rotating at synchronous speed. But what is the speed of rotor at that instant? 0. So what is relative speed between stator flux and rotor flux? Synchronous speed, which is very, very high. So because of that much relative speed, it is unable to produce any torque. That is, rotor poles are not able to catch the speed of stator poles. But in induction motor, stator flux, rotor flux both rotate at synchronous speed. So they are rotating. So easily it will catch the stator poles and torque will develop, it starts rotating, but not synchronous. That's why fourth option is correct in this. Okay, next. First read the question. Consider the following statements about operation of synchronous machine. This is completely armature reaction. See this first statement. Armature reaction in generating mode or in a generator aids means added the field flux when supplying a leading current. So just try to recollect. So in an alternator, What is the effect of armature reaction for leading power factor loads? Magnetizing effect. Magnetizing is added. Main flux, armature flux, both will be added. So this is right. Next, the armature reaction opposes the field flux for a motor under leading power factor. For the leading power factor, if alternator reaction is magnetizing, what is the reaction for generator? Demagnetizing. So that is opposition. No? Demagnetization means both the fields will be opposite direction. So this is also correct. And armature reaction in motor mode always opposes the field excitation irrespective of power factor. This is wrong. So A, B correct. A, B means which option? Second option is right. Okay. Next. In a salient pole synchronous generator, we need to find the relation between XD and XQ. So which is greater or both equal? So here XD always greater than XQ. Okay. Why? Because along direct axis, X proportional to flux and flux inversely proportional to reluctance, and this reluctance proportional to air gaps, air gap. So what is the gap along D axis? Minimum. If gap is minimum, that value of reactance along D axis will be more. So XD greater than XQ is correct. Next. In a grid connected synchronous generator working at UPF, increasing field excitation has the effect of. So this is from V inverted V curves. Generator connected to grid, alternator operating on bus bar or grid, and it is operating at UPF. Okay. From now, excitation increase. Whenever excitation increase, what happens to active power and reactive power? So if you remember, with the change in excitation, active power constant. But with the change in steam input, active power will change. So here, as excitation is changing, active power no change, but it is excitation increases. So reactive power supplied by alternator will increase. So you just try to reconnect that V inverted V curves, you can answer easily this one. Okay. Now from the option increasing, no, increasing only reactive power supplied to the grid. Active power no change. Fourth option is correct for this. Next, an electric machine wherein self-inductance of both stator and rotor windings are independent of rotor position. Independent of rotor position given. See this. Will not develop any torque. Which torque will not be developed? That is, answer is reluctance torque for this. Because reluctance torque mainly depends on position of rotor, but it is given independent of rotor position. So reluctance torque depends on position of rotor, but it is given independent here. That's why reluctance torque will not develop in this. This is correct. And remaining not possible. Hysteresis, rotor will not have any winding first, but given rotor winding also. That's why only reluctance torque will satisfy for this. Okay. So these are the questions from synchronous machines. Just try to verify whatever you did in the examination. Okay. Best of luck.
friends, coming to the discussion on digital electronics. Actually, 8 questions are given from the digital logic design and all the questions are from very basic level, and this is a direct conversion from hexadecimal to EF.A is a hexadecimal number. We need to convert it into equivalent decimal value, right? See, this is a general procedure, EF.A base 60. Just take the position value with its weighted value and then you will get 16 to the power of minus 1, 16 power 0 and 16 power 1. And just replace E with 14 and F with 15. Then you will get E into 16 plus F into 16 to the power of 0. Point. Replace F with 15 and replace A with 10. 10 into 16 to the power of minus 1. If you calculate it, you will get 239.625 in decimal. This is the direct conversion method from hexadecimal to decimal. Option A is the correct answer. Choose the correct statement. It is purely a topic from ECE, FSM, finite state machines. There are 2 types of machines we have, Mealy and Murray machine. Coming to the definition of a Mealy finite state machine. In Mealy finite state machine, output is depends on present state and input. I am just writing PS, here PS stands for present state and input. Whereas in Murray FSM, output depends on present state only. If you see all the options, Murray and Mealy machine, output does not depends on input. No, actually output depends on input in case of Mealy. So option A is wrong. Option A is wrong. Even option 2 is wrong. Even option 1, you see both Mealy and Murray, common statement is given on both depends on the current state. No, not like that. In case of Murray, output is depends on only present state. That is the reason A and B and 1 and 2 are wrong options. If you observe the option 3, Murray and Mealy machines, outputs depends on inputs. No, actually in case of Murray, output is not depends on input. It depends on only present state. What is the common point here? State, present state. So that you can see in option 4. Murray and Mealy machines outputs depends on current state, and this is a valid correct answer for the statement. So option 4 is the final and correct answer. Find the minimized expression for the given Z is equals to is a direct expression. We can simplify it in just 2 steps, xy bar plus xy. You can take the common term here. If you take common term as x, what will be the resultant? Y plus y bar. What is the value of y plus y bar? 1. So you will get this as x plus this is x bar y. We have studied this in redundant literal rule. As per the redundant literal rule, x plus x bar y is equals to x plus y. 4 is the correct option. 4 is the correct option. The octal representation of some binary number is dash. 1111 000 1000 1 is given. We are going to convert it into octal. So we know the technique. What is the base value of octal? 8. We can write it as 2 to the power of 3. Okay. We are going to group 3 bits from the binary. 3 bits, 3 bits. If you group like that, you will get 111. What is the equivalent value? 7. And this is equals to 4. 2 and 1. 7, 4, 2, 1. This is given in option 3. What is the hexadecimal value, equivalent value? Direct I am writing here only, right? 1111, that is equals to, direct we need to group 4 bits from the binary, and that will gives F with the base 16. Option 2. Two 10-bit analog to digital converters, one of the successive approximation type and other of single slope integration type. You might have studied this single slope integration type in ramp type DVM. Take T and TB time respectively. Time means it's a conversion time. We have discussed. Conversion time is actually the time required to convert the input analog data into digital. ఇది మనం అనలాగ్ టు డిజిటల్, డిజిటల్ టు అనలాగ్లో డిస్కస్ చేసాం క్లాస్లో. బట్ ఇఫ్ యూ సీ ADC and DAC, you cannot find this single slope. It is related to ramp type digital voltmeter, right? ఇక్కడ మనకి లింక్తో క్వశ్చన్ ఇచ్చాడు. సో ట్రై టు అండర్స్టాండ్. We need to get back the conversion time formulas. What are the formulas for conversion time of successive approximation type? Successive approximation type conversion time, he is given that TA. TA value ఏమి ఇచ్చాడు? Sir, TA, TB are the notations actually. But this is a TA time requires to convert if it is a 3 volts. And TB time requires to convert if input is a 3 volts. By using two systems like first one successive approximation and second one ఏమి ఇచ్చాడు? Ramp type ఇచ్చాడు. So what is the formula first? You write the formula. Successive approximation n into TC. TC అంటే clock duration, right? And TB 2 to the power of n minus 1 into TC. Now you read the question. If the time taken by those two systems TA and TB for 3 volts, what is the time for 6 volts? ఇక్కడ మీకు వోల్టేజ్ రిలేషన్ ఏం లేదు టైం. అంటే వోల్టేజ్ వేరీ చేసినప్పటికీ there is no difference in the maximum conversion time. Maximum conversion time ఎవరి మీద డిపెండ్ అయి ఉంది? n value. n represents number of bits. There is no data related to number of bits. That is the reason there is no change. So time will be remains same, that is TA will becomes TA, TB will becomes TB. Whatever may be the time for 3 volts, same time in case of 6 volts also, it's only depends on number of bits, n value, right? Following gates, which of the following are the universal gates? NAND and NOR are universal gates, right? This is a direct question. And option 1. Remaining all cannot be the universal gates. We cannot select NOT gate, OR gate, AND gate, as there is a XOR and XNOR here. We cannot select option 4 also. Yes. What is the signal to noise ratio of a 10-bit ADC? Actually, for a standard under ideal conditions, of course, ADC signal to noise ratio formula is 6.02 into n plus 1.76 dB in decibels, where n represents number of bits. If you substitute the n value, n is equals to 10, you will get 61.96 dB. Okay guys, these are the questions given from digital electronics.
Right. Now I would like to discuss the questions from electrical and electronic measurements. Generally from this measurement subject, in almost all AE examinations, the general weightage is around 8 marks we say, or 6 to 8 marks. Here also, in this year also, same thing, 6 to 8 question means in this year 6 questions were there. Now let us see the first question. The ammeter has a range. This is the question related to extension of range of the corresponding meter. What is the given data here? This is the corresponding range of the device, that is IM is given, and this is the internal resistance REM, right, meter resistance is given. He wants to extend this range. He wants to extend this range to 30 ampere. So therefore simply what you require in order to extend the range of current, the first one is we require shunt element. We require shunt element. So therefore by observing this you can eliminate two options here. One is shunt and shunt here, series and series. Therefore these two options can be eliminated. Now the second one is both options are given with shunt only. So therefore we are supposed to find out the value. What is the value here? RSH is equal to REM by I by IM minus 1. This is general formula. If you substitute all these values, this is IM, this is REM and this is I. If you substitute that, you are going to get the value as 0.05 ohm. So therefore the answer here is the first option. Very, very simple question based on the extension of range. Now the next question is, this is also straight away question from the bridges. Which bridge is used for measurement of frequency? It is a straight away question. That is, Wien's bridge is used to measure the frequency, and other bridges are Anderson inductance, Maxwell's inductance, sharing bridges for capacitance. So obviously answer will be Wien's bridge. Now next question is a dynamometer type wattmeter. This is a little bit conceptual one. It is a wattmeter. Every wattmeter will be having two coils, that is one is a current coil and other one is potential coil, like this, current coil as well as potential coil. Generally the current coil will be connected with the load. So therefore in the current coil the current will be more and in the potential coil the current will be less. So that's what the question. Which option is correct, right? Current in the fixed coil. Current coil is nothing but fixed coil, and potential coil is also called as moving coil. So therefore current in the fixed coil is lower than the moving coil, but current in the fixed coil is higher. So therefore this is wrong. And here cannot comment. Yes, we can comment, actually it is also wrong. Current in the fixed coil is same, so therefore it is also wrong. So finally the correct answer is the fourth option. Current in the fixed coil is more than the current in moving coil. Yes, this current is more than the moving coil current. Straight away fourth option. Right, next question. Here small ambiguity is there in this question. That is, he wants to measure the relative permeability, but options are given as sharing bridge, Anderson's bridge, Wheatstone bridge and Kelvin bridge. Suppose in the question you would have they have given that relative permittivity. If they give relative permittivity, right, we can use sharing bridge, that is scaling bridge we say. But he has given permeability. So permeability is related to coil concept, that is inductive concept. So based on that, among all these two bridges are for resistance measurement. This bridge is purely, what is it, relative permittivity. So among the available options we can say the suitable option is Anderson, we can say. But if they would have thought that it is relative permittivity, definitely answer will be sharing bridge. So these are the questions from measurement subject.
let us try to solve the questions which are given from power systems. So observe this fourth question that was given. A synchronous generator rated 11 kV 50 MVA has a per unit impedance of 0.2 per unit on its own base. Then its impedance referred on a base of 22 kV 150 MVA. Here we need to change the base. So what is the procedure? Z per unit new is equal to Z per unit old into MVA new by MVA old multiplied with kV old by kV new square. So what is the Z per unit old value given as 0.2, MVA new is 150, MVA old is 50, kV old given as 11 and kV new is 22 square. Okay. So this gets cancelled out, 5 3 is 15, this is 0.6 into this is 11 1s are 11 2s are 1 by 4. So you will get it as 0.15 per unit. So here the answer stands first one. Now let us observe this question. Which of the following machines is most suitable for installation of generator in a coal-fired thermal power plant? So in thermal power plant we can attain high speeds. So for high speeds which type of generators and constant speed we can maintain? So induction generator will not be the option. So synchronous generator is the option. So as we can obtain high speed operation, so we will go for what? Cylindrical rotor synchronous generator. So which of the following relays used for the transmission line protection which has been inherently directional? So observe this point, inherently directional. So which relay is inherently directional? Only the relay MO relay is inherently directional, remaining all are what? Non-directional relays. Now observe this question. A Buchholz relay is commonly used for protection of which of the following? Buchholz relay, which is a gas activated relay used in transformer protection. So observe these options, third option is the right one. Buchholz relay is used in transformer protection. Now observe this one. Which of the following is the purpose of using harmonic restraint function in power transformers? So why you are using the harmonic restraint coil in case of power transformers? Mainly when the magnetic inrush current is very high, the differential relay may result in maloperation. That's why we will be using second harmonic restraining coil. So option stands 1, to prevent the false tripping due to magnetic inrush current. Now observe this question. 3-phase 33 kV oil circuit breaker rated 1500 ampere 2000 MVA 2 seconds. So what is asking to calculate? Symmetrical breaking current. That is nothing but the rated current of the breaker itself. Okay. So here symmetrical breaking current ela calculate chesaru? Symmetrical breaking current is nothing but S by root 3 times of VL. So apparent power rating ఎంత ఇచ్చారండి ఇక్కడ 2000 MVA. So 2000 into 10 power 6 by root 3 into voltage 33 kV ఇచ్చారు. 33 into 10 power 3. So ఇది క్యాలిక్యులేటర్ అవసరం ఇది క్యాలిక్యులేట్ చేయడానికి. So 35 kilo amperes is the answer. So option 4 is the right one. ఈ క్వశ్చన్ అబ్జర్వ్ చేయండి ఇక్కడ. సో reduce the Ferranti effect. Ferranti effect ఎలా reduce చేస్తామండి? Ferranti effect is reduced by using a shunt reactor. So A stands for 2. Okay. So power factor improvement కోసం మనం shunt capacitor వాడతాం. B stands for 3. Increase power flow capability series capacitor. So C stands for 1. Reduce the ripple current series reactor. D stands for 4. Okay. So observe this question. The surge impedance of 300 km long overhead line is 180 ohms. 300 km line ది 180 ohms అన్నాడు. 150 km లైన్ లెంత్ కి సర్జ్ ఇంపిడెన్స్ ఎంత ఉంటుంది అని అడుగుతున్నాడు. లైన్ లెంత్ పైన డిపెండ్ అవ్వదు. కాబట్టి ఆన్సర్ ఏంటి? 180 ohms. So these are some of the questions from power systems. Remaining questions will be discussed by our colleague.
Hello everybody, welcome back. So this is the next question in the power system. So here they are asking the power loss in the power system network. They are given if the value of complex power is given and if V is the voltage, sending end voltage, then what are the power losses? We know the power loss equation. First of all, the power transfer equation is P is equivalent to VI cos phi. And from this one, we can calculate the current I. What is the current I is nothing but PT divided by V cos phi. And from this one, what are the power losses? The power loss are nothing but I square R. From this one, substitute the value of I, it will be PT divided by V cos phi whole square into R. Therefore, from this one you can write power loss are inversely proportional to V square. Therefore, the correct option is option 2 is the correct answer, right? And the next question is, consider the following statements they have given about the sequence networks, one of the easiest question. So we know for generator, the sequence networks for generator. For generator, the positive sequence reactance is the highest value and it is somewhat slightly equal or somewhat slightly more than that of the negative sequence reactance, and it is more very high compared to that of the zero sequence reactance. And in case of transformer, for transformer, all are equal, positive sequence, negative sequence and zero sequence reactance are exactly equal. And for transmission line, the positive sequence reactance and negative sequence reactance are exactly equal and they are very, very less than that of the zero sequence reactance. And if you read the statements clearly, you can write, so for a fully transport transmission line, positive sequence and negative sequence reactance are exactly equal. It's true. And option B, that is second statement, the negative sequence impedance of a synchronous generator is usually smaller than that of the positive sequence, so that it's also true. And third one, the negative sequence impedance of transformer is generally much higher. That's the wrong one. So that we can go for A and B are correct. A and B are correct. So that here it is A and B are correct. Clear? And the next question here it is, which of these is responsible for developing the pressure in the working fluid cycle in a thermal power plant? So this question we have given directly in the test 2 conducted by the AS Engineering Academy. So direct as it is options also we have given there, so that it is feed water pump, right? So feed water pump is the responsible for working pressure there. And the next question, one of the easiest question, direct answer question, Gauss-Seidel method where we are using. The method itself is called as Gauss-Seidel load flow method. So we are using in load flow analysis, right? And the next question is, which of the following could be the effect of using high-speed circuit breaker? Why we are using high-speed circuit breakers? So to improve the stability of the system, right? So to improve the transient stability of the system, we are going to use the high-speed circuit breakers, right? So to improve the system stability, right? And the next question here it is, in this question, the line impedance is given 5 plus J10 and the apparent power supplied by the system is given and voltage is also given and they are asking the line losses, right? So this is the same question whatever already we have discussed. Just check here. The line resistance is given 5 ohms and they are asking the power loss, which are nothing but I square into R. To calculate I, they have given the power ratings where S is equivalent to √3 times of V line into I line. From this one, what is I line is equivalent to S divided by √3 times of V line. Substitute S value as 100 MVA and V line as 400 kilovolts and you can get the value of IL. And substitute that IL value here, you can get the power loss value and it is approximately 104 kilowatt we got per phase, right? So this is the per phase value they have given. But for 3 phase they have not given the options clearly. For per phase only they have given the option, right? And the next question, direct statement they have given here, statement of Ferrand effect. What is Ferrand effect? Under no load or lightly loaded condition, whenever the receiving end voltage is more than that of the sending end voltage, we can call that phenomena as the Ferrand effect, right? So this is the Ferrand effect in the transmission system, right? Right. These are the questions in power system. Next we will discuss the questions in utilization. Welcome back everybody. So now we'll start the questions in the utilization of electrical energy. So here, what is the unit of illumination? The unit of illumination is direct question here. The unit of illumination is lux. Right? There is no confusion at all in the given options. So coulombs, decibels and Henry are different units, but lux is given directly. If they have given some different lumens per watt like that, there will be confusion, but they have given very clearly, right? And the next one is, they are asking, if a lamp takes 10 amperes at 250 volts and emits total flux, right, 16,000 lumens, then determine mean spherical candle power. So what is that mean spherical candle power? MSCP. MSCP is equivalent to total flux, total illumination flux, you can write, illumination flux, divided by 4 pi. So that it will be total illumination flux given is 16,000 divided by 4 pi, it will be 4,000 by pi. 4,000 by pi, right? So that the correct answer is 4,000 divided by pi. That is the correct one. And the next question here it is, what is the effect on coefficient of adhesion due to following conditions on rails? We know whenever the rail is dry, the coefficient of adhesion will be very high, right? So that the coefficient of adhesion will be very high whenever the rails are dry. So that is the correct answer, right? And the next question is, which of the following load offers characteristics close to constant load torque? Constant load torque are hoists, right? So whenever cranes are hoisting, so the load torque will be constant, right students? And the next one is, which of the following is used in overhead power supply for AC traction locomotive? For traction locomotive it will be 25 kilovolts, 50 Hz single phase. 25 kilovolts, 50 Hz standard notations, right? And the next question, what happens in coasting mode? So in case of coasting mode, we'll cut off the power supply to the train, and the train runs because of its inertia, right? So that if you see that options, the power supply is cut off and the train is allowed with the own inertia, right? That is the correct answer for that question. That is the coasting period. And which type of transformers is used in AC traction, right? Or AC welding. AC welding we can use it as step down type. Step down type transformers are used in AC welding. And the next question is, what is the filament used in incandescent bulb? It is tungsten filament, right? So tungsten filament is used in the incandescent bulb, right? So these are the questions we are having in utilization of electrical energy, right?
Now we are going to solve questions related to signals and systems. ఇప్పుడు ఈ క్వశ్చన్లో బౌండెడ్ సిగ్నల్ ఏది అని అడిగాడు. సో ఫస్ట్ సిగ్నల్ చూడండి, ఇలా ఇంక్రీజ్డ్ ఆసిలేషన్స్ వెళ్తుంది, ఇది బౌండెడ్ కాదు. సెకండ్ సిగ్నల్ చూడండి ర్యాంప్, ఇది కూడా బౌండెడ్ కాదు. థర్డ్ సిగ్నల్ ఎక్స్పోనెన్షియలీ ఇంక్రీజింగ్, ఇది కూడా బౌండెడ్ కాదు. సో మన ఆన్సర్ ఏంటి? ఆప్షన్ 4. ఒకవేళ మీరు ఆప్షన్ 4 డ్రా చేస్తే ఇట్ ఈస్ ఎక్స్పోనెన్షియలీ డీకేయింగ్. సో ద ఆన్సర్ ఫర్ దిస్ క్వశ్చన్ ఇస్ ఆప్షన్ 4. విచ్ ఆఫ్ ద ఫాలోయింగ్, ఓకే ఇక్కడ జీరో ఆర్డర్ హోల్డ్ సర్క్యూట్ ట్రాన్స్ఫర్ ఫంక్షన్ అడిగాడు. దాని ఇంపల్స్ రెస్పాన్స్ ఏంటో చూద్దాం. దాని ఇంపల్స్ రెస్పాన్స్ h of t ఈక్వల్ టు u of t మైనస్ u of t మైనస్ క్యాపిటల్ T. ఇది ఇంపల్స్ రెస్పాన్స్ అయితే దీని లాప్లాస్ ట్రాన్స్ఫార్మ్ అప్లై చేస్తే ట్రాన్స్ఫర్ ఫంక్షన్ వస్తుంది. సో లాప్లాస్ ట్రాన్స్ఫార్మ్ అప్లై చేయండి. హెచ్ ఆఫ్ ఎస్ ఈక్వల్ టు 1/s మైనస్ e పవర్ మైనస్ s ఇంటూ క్యాపిటల్ T బై s. సో ఆప్షన్ 3 కరెక్ట్. లాప్లాస్ ట్రాన్స్ఫార్మ్ ఆఫ్ ద డిఫరెన్షియల్ ఈక్వేషన్, మనకు ఒక డిఫరెన్షియల్ ఈక్వేషన్ ఇచ్చి దానికి లాప్లాస్ ట్రాన్స్ఫార్మ్ అప్లై చేసి కరెక్ట్ ఆప్షన్ చూస్ చేసుకోమంటున్నాడు. ఇనీషియల్ కండిషన్స్ కూడా ఇచ్చాడు. సో ఆ ఇనీషియల్ కండిషన్స్ని జాగ్రత్తగా అబ్జర్వ్ చేయాలి. సో లాప్లాస్ ట్రాన్స్ఫార్మ్ అప్లై చేయండి. దీని లాప్లాస్ ఏమవుతుంది? s స్క్వేర్ y ఆఫ్ s మైనస్ s ఇంటూ y ఆఫ్ 0 మైనస్ y డాష్ ఆఫ్ 0. ఇది లాప్లాస్ ఆఫ్ ద ఫస్ట్ టర్మ్ ప్లస్ వాట్స్ ద లాప్లాస్ ఆఫ్ ద సెకండ్ టర్మ్? a ఇంటూ s ఇంటూ y ఆఫ్ s మైనస్ y ఆఫ్ 0. నెక్స్ట్ b ఇంటూ y ఆఫ్ s ఈక్వల్ టు f ఆఫ్ s. ఇది కనుక ప్రాపర్గా అరేంజ్ చేసి ఇచ్చిన ఇనిషియల్ కండిషన్స్ వాడితే మీకు కరెక్ట్ ఆన్సర్ వస్తుంది. సో s స్క్వేర్ ఇంటూ y ఆఫ్ s మైనస్ s ఇంటూ y ఆఫ్ 0 ఎంత ఇచ్చాడు? 5 ఇచ్చాడు. సో 5 s ఇంటూ 5 ఓకే మైనస్ y డాష్ ఆఫ్ 0 10 ఇచ్చాడు ప్లస్ a ఇంటూ s ఇంటూ y ఆఫ్ s మైనస్ y ఆఫ్ 0 5 ప్లస్ b ఇంటూ y ఆఫ్ s ఈక్వల్ టు f ఆఫ్ s. ఇక్కడ మనం f ఆఫ్ s అని తీసుకున్నాం, కానీ ఆప్షన్స్లో వాడు బై ప్రింట్ మిస్టేక్ r ఆఫ్ s అని ఇచ్చాడు. కంగారు పడక్కర్లేదు, జస్ట్ ఫామ్ చూడండి ఎలా ఉందో. సో మైనస్ 5s ఉంది, మైనస్ 10 a ఇంటూ sy మైనస్ 5. సో ఆప్షన్ 3 కరెక్ట్. ఇది ఫోరియర్ సిరీస్ గురించి ఇచ్చాడు. ఇచ్చిన క్వశ్చన్లో f ఆఫ్ x ఈవెన్ ఫంక్షన్ అంటున్నాడు. మీరు ఒక పీరియాడిక్ సిగ్నల్ ఒకవేళ అది ఈవెన్ అయితే సో అందులో సైన్ టర్మ్స్ ఉండవు. సైన్ టర్మ్స్ ఉండవు అంటే దీని కోఎఫిషియంట్ bi ఖచ్చితంగా 0 అవ్వాలి. సో ఈ క్వశ్చన్కి ఆన్సర్ ఏమవుతుంది? bi 0. చాలా సింపుల్ క్వశ్చన్స్ అడిగాడు. సో నెక్స్ట్ క్వశ్చన్ చూద్దాం. ఇది కూడా ఫోరియర్ సిరీస్కి సంబంధించింది. మనకు ఒక ఫంక్షన్ ఇచ్చాడు f ఆఫ్ x x ప్లస్ పై అని. దాని పీరియాడిసిటీ వచ్చి 2π. సో దీని ఫోరియర్ సిరీస్ రిప్రజెంటేషన్ ఏమవుతుంది అని అడుగుతున్నాడు. 4 ఆప్షన్స్ ఇచ్చాడు. ఇది కనుక మీరు డీటెయిల్డ్గా అంటే అనలిటికల్గా సాల్వ్ చేస్తే చాలా టైం అవుతుంది. చూద్దాం ఇది ఒక 1 minute ఎలా సాల్వ్ చేయగలుగుతామో. ఫస్ట్ నేను ఏం చేస్తానంటే డీసీ వాల్యూ అనుకుంటాను దీన్ని. సో డీసీ వాల్యూ ఎలాగ అనుకుంటాం? డీసీ వాల్యూ ఇస్ 1/2π ఇంటిగ్రల్ మైనస్ π టు π. అంటే ఒక ఫండమెంటల్ టైం పీరియడ్లో ఇచ్చిన ఫంక్షన్ ఇంటిగ్రేట్ చేయాలి, ఆ ఫండమెంటల్ టైం పీరియడ్తో డివైడ్ చేయాలి. సో ఇంటిగ్రేట్ చేయండి. x ప్లస్ π dx. ఎక్స్ని ఎప్పుడైతే ఇంటిగ్రేట్ చేస్తారో మైనస్ π టు π, ఈ ఒక్క రిజల్ట్ 0 అవుతుంది. సో ఏం మిగిలింది? పైని ఇంటిగ్రేట్ చేయాలి. పైని ఇంటిగ్రేట్ చేస్తే పై కాన్స్టెంట్, పై ఇంటూ 2π బయటికి వస్తుంది. సో బై 2π ఇది క్యాన్సిల్. డీసీ వాల్యూ వచ్చి పై, డీసీ వాల్యూ పై. ఇక్కడ చాలా జాగ్రత్తగా కనుక మీరు ఆలోచిస్తే ఏదైనా ఒక వే ఫామ్లో డీసీ ఉంటే దాన్ని సబ్స్ట్రాక్ట్ చేసి అనలైజ్ చేయండి, చాలా ఈజీగా ఆన్సర్ రాబోతుంది. ఇప్పుడు నాకు వచ్చిన డీసీ వాల్యూ వచ్చి పై. ఆప్షన్స్లో ఫస్ట్ ఆప్షన్ థర్డ్ ఆప్షన్లో డీసీ వాల్యూ పై ఉంది, మిగతా ఆప్షన్స్లో లేవు. సో ఫస్ట్ ఇది ఎలిమినేట్ చేశాను ఎందుకంటే డీసీ వాల్యూ π/2 కాబట్టి. ఇప్పుడు నెక్స్ట్ ఇందులో కాస్ nx టర్మ్ ఉంది, ఇందులో సైన్ nx టర్మ్ ఉంది. జాగ్రత్తగా మీరు డీసీ వాల్యూని సబ్స్ట్రాక్ట్ చేసి అనలైజ్ చేస్తే ఆబ్వియస్గా ఆన్సర్ వస్తుంది. సో ఇచ్చిన ఫంక్షన్లోంచి నేను డీసీ వాల్యూ సబ్స్ట్రాక్ట్ చేస్తే, సో ఐఎమ్ సబ్స్ట్రాక్టింగ్ డీసీ వాల్యూ, దట్ ఈస్ x ప్లస్ π మైనస్ π. సో ఇది క్యాన్సిల్. జస్ట్ ఇమాజిన్ చేయండి, ఏం మిగిలింది? ఉట్టి x మిగిలింది. ఉట్టి x డ్రా చేస్తే ఎలా ఉంటుంది? ఇలా ఉంటుంది. అంటే ఇది ఒక ఆడ్ ఫంక్షన్. ఆడ్ ఫంక్షన్ పీరియాడిక్ అంటే ఆడ్ ఫంక్షన్ ఫోరియర్ సిరీస్లో సైన్ x టర్మ్స్ మాత్రమే ఉంటాయి. ఆప్షన్స్ని చూడండి ఒకసారి. ఇందులో కాస్ nx టర్మ్ ఉంది, ఇందులో సైన్ nx టర్మ్ ఉంది. ఇంకేం ఆలోచించకుండా ఆప్షన్ 3 మన కరెక్ట్ ఆన్సర్. సో దీస్ ఆర్ ద క్వశ్చన్స్ ఫ్రమ్ సిగ్నల్స్ అండ్ సిస్టమ్స్.
Hello everyone. Now we are going to discuss the questions related to the power electronics. Altogether there were 21 questions. Hardly 3 questions require some calculations. Remaining questions are straightforward. Let us discuss one by one. A 3-phase diode bridge rectifier supplied from a 3-phase 400 volt 50 Hz AC supply delivers power to a resistive load of 50 ohm. The peak value of instantaneous load voltage, they are asking the peak value of instantaneous load voltage, that is output voltage, peak value instantaneous, but okay. Now here they are talking about the 6 pulse uncontrolled rectifier. We know in the case of 6 pulse uncontrolled rectifier, the output is in the form of line voltage, input line voltage. So what is the output voltage peak value? Yes, V0 peak instantaneous value is equal to VML, that is the peak value of supply line voltage, which is equal to, now here, root 2 into VL RMS, right? It is root 2 into, what is VL RMS? They have given it as a 400 volt, right? VL RMS is a 400, so it is a 400 into root 2 volt, 400 into root 2 volt. So if you check, the option, correct option is option 3, alright. Next, what is the low order ripple frequency of the output voltage of a 3-phase fully controlled bridge converter if the AC supply frequency is a F Hertz? If supply frequency is a F Hertz, then what is the output ripple frequency? We know in a case of 3-phase full converter, we are getting the 6 pulses in output. So output pulse frequency or ripple frequency is 6 times the supply frequency. So the answer is 6 into F. Answer is 6 into F. That is second option, right? Next, which of the following armature voltage control method is employed when the supply is DC? When supply is DC, then in order to control the armature voltage, that is the DC voltage we want as an input to our motor, okay. So we, out of these, which converter we are having that converts the DC to variable DC? Yes, chopper control. The chopper converts fixed DC to the variable DC, alright. Next, a single phase diode bridge rectifier is used to supply a highly inductive load. If the load current is assumed to be ripple free, then the input current at the AC side of the rectifier will be, they are talking about the supply current, that is a source current, right? During our classes we have discussed, here they have given single phase diode bridge rectifier, right? And input load is highly inductive means load current is a constant. If load current is constant, then what is the nature of the source current? Source current is a square wave, alright? Source current is a square wave. Consider the following statements about 3-phase voltage source inverter. First statement is they require voltage bidirectional 2-quadrant devices to realize the switches. Here they are talking about the voltage source inverter, that is VSI, right? We know in a VSI we require which type of the switches? In a voltage source inverter, unipolar and bidirectional switches are required, right? Unipolar and bidirectional, unipolar and bidirectional switches are required. But here they are talking about they require a voltage bidirectional 2-quadrant device. Please understand this. Voltage bidirectional, the meaning is voltage bidirectional means it is a bipolar switch. Okay? Voltage unidirectional means unipolar. Voltage bidirectional means it is a bipolar switch. Okay? But we require unipolar here, and here they are saying that this is a bipolar, so this is not true. Second is PWM techniques are used to reduce the frequency of the harmonics in the output. Yes. And third statement is in a 1-degree conduction mode, a new switch is gated in every 60-degree duration. Yes, check the operation table of 180-degree conduction mode. After each 60-degree new switch you are triggering, na? Alright. So therefore option second and third, that is B and C statements are correct. So correct answer is option 4. Alright, please understand this. Voltage bidirectional means it is a bipolar. Voltage unidirectional means it is a unipolar. Alright, yes. Next, which among the following is an example for a voltage bidirectional 2-quadrant switch? Again the same. Voltage bidirectional 2-quadrant means it is, they are talking about bipolar switch. Bipolar. Now tell me, out of these two, which switches are bipolar? Yes, SCR is a bipolar, na? MOSFET, BJT diodes, right? All right, only SCR is a bipolar switch. So correct answer is option 2, right? Correct answer is option 2. Consider the following statements about the phase controlled single phase full bridge converter using SCRs. Okay. The average output voltage at the DC side varies linearly with the firing angle. Whether our output voltage varies linearly? No, it is proportional to cos alpha, na? So first statement is not correct. The power factor at the AC input side depends on the converter firing angle. Yes, input side power factor is equal to 0.9 into cos alpha, na? Right? So this statement is true. The converter cannot be operated with firing angle greater than 90 degree. Is it correct? No. So this is not true. We can operate for greater than 90 degree even. Alright. So correct answer is only option B. That is, B statement is correct, means option 1 is the correct. Alright. Next. The MOSFET in the circuit shown below is operated as a switch at a frequency of 10 kHz and a duty ratio of 0.6. The initial inductor current is 0. If all components can be assumed to be ideal, what would be the energy stored in the inductor at the end of 10 switching cycles? So guys, this question they have asked in the previous GATE examination also. As it is, they have copied the question. Okay, no values also, they have not changed the values. Okay, let us discuss how to solve this. Okay, one of the important question. Yeah, so here they have given this circuit diagram. If you check, this is a buck boost converter. All right, so it is a buck boost converter. It is given that supply voltage is 50 volt. Output voltage is also 50 volt. Supply voltage 50 volt, output voltage 50 volt. Inductor L is equal to 10 millihenry. Next, duty cycle is 0.6. Inductor value is, switching frequency is 10 kilohertz. F is equal to 10 into 10 to the power 3 hertz. Our task is to find energy stored by the inductor, right, at the end of first 10 cycles. Inductor energy. Energy stored by inductor at end of 10 cycles. So guys, here they have given the supply voltage, load voltage as well as the duty cycle. If you recall, in our classroom sessions also we have discussed, if they give the supply voltage, load voltage and duty cycle, the very first step we are required to perform is check whether the conduction is a continuous or discontinuous. Alright, so let us check first. Check whether conduction is a continuous or discontinuous. Continuous or discontinuous. Right? So for continuous conduction, what is output voltage? For buck boost converter, it is D upon 1 minus D into Vs. Alright. So now put the value of given duty cycle and the supply voltage and check what is the output voltage you are getting. So duty cycle is 0.6 upon 1 minus 0.6 into Vs is 50 volt, right? So it is equal to 6 by 4 into 50, that is equal to 75 volt. So my output voltage, if the conduction is continuous, then it is a 75 volt. This is for continuous conduction. But what is the output voltage they have given? They have given output voltage as 50 volt. Now tell me the given output voltage is less than the output voltage of continuous conduction, na? Right? So here can we say that the conduction is a neither continuous nor discontinuous, it is an unstable operation. Please understand it. If given output voltage is greater than the continuous conduction output voltage, then it is like your conduction is a discontinuous. But in this case, the given output voltage is 50 volt. Given output voltage is 50 volt. This output voltage is less than the continuous conduction output voltage. So therefore my conduction is a yes neither continuous nor discontinuous. So it is a unstable operation. Operation is unstable. So for unstable operation, how to find the value of energy stored by the inductor at the end of 10th cycle? Let us discuss. Okay. So during first on time, during first on time, that is t equal to 0 to dt. Yes, during first on time my switch will be in a on state, alright. So what is the voltage across inductor? Yes, can we write? Voltage across inductor, that is VL is equal to, when this is in a on state, VL is equal to 50 volt, alright. So VL equal to 50. I can write VL equal to 50. But VL means L into DIL by dt is equal to 50. Alright. Now during the first on time, how is my inductor current waveform? First on time means inductor current waveform will be like this. It will increase from 0 to dt. Because when switch is in on state, your inductor will store energy. And they have given initial inductor energy is a 0. Initial inductor current is 0. So therefore current starting from 0. So during the first on time, inductor current will go on increasing. Okay. Let me consider this current is I1. Let me consider this current is I1. Alright. Now here, can we write L into DIL by dt means L into DIL is nothing but change in the inductor current. Inductor current changes from 0 to I1. So final value is I1. Initial value is 0. I1 minus 0 upon dt means on time is equal to 50. So from this I can write I1 is equal to 50 into dt, d is 0.6 into t is 1 by frequency. Frequency is 10k na, 1 upon 10 into 10 to the power 3 upon this L. L value is 10 into 10 to the power minus 3. So if you check, this is plus 3 minus 3 will get cancelled out. It is 30 by 100, that is 0.3 ampere. So my I1 is a 0.3 ampere. I1 is equal to 0.3 ampere, means this current is 0.3 ampere at the end of first on time. Next, during the first off time, please understand this question is important. During first off time, that is t equal to dt to capital T. T equal to dt to capital T. Now tell me, during the first off time means when switch is in an off state. When switch is in an off state, your inductor will go on releasing energy. Na? This diode will start conduction. Then when diode starts conduction, what is VL? VL is equal to minus 50 volt. Okay. So I can write here VL equal to minus 50 volt. But VL means L into DIL by dt, which is equal to minus 50. Now here what the inductor is doing? Inductor is releasing energy, na? Right? So for the first off time, my inductor current will go on decreasing because inductor is releasing energy. 0 to dt on time, dt to t off time. Inductor is releasing energy. Let me indicate this current is I2. This current is I2. Now tell me during first off time what is DIL? inductor change in inductor current is I2 minus I1. So I can write it as L into I2 minus I1 upon dt means T minus dt is equal to minus 50. Alright. So now we can simplify this. It is equal to L into I2 minus I1 is equal to minus 50 into 1 minus d into t. So therefore I2 minus I1 is equal to minus 50 into 1 minus d is 0.6 into t is 1 by frequency, that is 10k, 1 by 10k. Upon inductor value 10 into 10 to the power minus 3. Alright. Yes. Now we can simplify this and we can write I2 minus I1 is equal to minus 0.2 ampere. So therefore what is I2? I1 minus 0.2 which is equal to 0.3 minus 0.2 which is equal to 0.1 ampere. Means I2 is a 0.1 ampere, right? I2 is a 0.1 ampere means here my I2 value is a 0.1. So what is happening here? During first on time inductor current increases from 0 to 0.3. During first off time my inductor is releasing energy but current is not coming to 0. Current is reaching to which value? Only 0.1 ampere, right? Means here whatever energy stored by the inductor and energy released by the inductor both are not equal. So that's why it is unstable operation. So what is happening at the first end of the first cycle my inductor current is 0.1. Similarly for the next on time what will happen? My inductor current will again reach, will go on increasing and again it will decrease. At the end of second on time, at the end of first on time, at the end of first cycle my inductor current increased from 0 to 0.1. During the second cycle my inductor current will change from 0.1 to which value? 0.2 ampere here. Similarly tell me at the end of 10th cycle what is the current flowing through the inductor? It is a 1 ampere. So I can write at the end of 10th cycle, at end of 10th cycle inductor current value IL is equal to 1 ampere. Therefore energy stored by inductor half into Li square which is equal to 1 by 2 into 10 into 10 to the power minus 3 into 1 square, right? So if we simplify it we will be getting it as a 5 millijoule. It is a 5 millijoule. Alright. Yes, 5 millijoule. So if you check the options, correct option is 0.005 joule. Alright. Yes. Next, a 3-phase full controlled converter with 6 SCRs only is feeding the armature of a separately excited DC motor. The motor has to also operate in a quadrant 3. Motor has to operate in a quadrant 3. Quadrant 3 means voltage as well as current both should be negative, right? Third quadrant means VA negative and IA also we require negative, right? So if you want VA negative, IA negative, then by operating with triggering angle alpha greater than pi by 2, that is true. Second, by connecting a freewheeling, but only doing alpha greater than pi by 2 is not sufficient, okay? Because in the inverter mode operation of rectifiers we have discussed, for inverter mode operation only alpha greater than 90 degree will not reverse your load current, okay? So here the thing is, if you check the options carefully, right? The correct option is by adjusting the triggering angle alpha followed by armature connection reversal. Means fourth option is the correct option. Alright? Yes. Next, in a sleep power recovery scheme of 3-phase induction motor drive, what is the operating speed of with respect to the synchronous speed of the motor if the power is injected into the rotor circuit from an external source? In a sleep power recovery scheme, the motor operating speed is always less than the synchronous speed. Motor speed is always below the synchronous speed. Option 1 is the correct option. Alright. What is the effect of AC side source inductance in SCR based phase control rectifier operating with a firing angle less than pi/2 radians during REL type loading condition compared to that in zero source impedance condition? Means what is the effect of source inductance they are asking. What is the effect of source inductance? We know source inductance reduces the output voltage. Okay, so if you check the options, correct option is option 4, average output voltage decreases. Alright. Next, the minimum value of anode current in an SCR that is required to sustain the conduction in a thyristor with a zero gate current is called. Right. Yes, it is straightforward, the definition of the latching current. Minimum anode current required to maintain SCR into on state. Okay, when we remove the gate signal. Okay, right. So correct answer is option 3, latching current. Consider the following statements about a triac. Very simple question. A triac has bidirectional current carrying capacity as well as bidirectional voltage blocking capacity, right? We know triac is a bipolar and bidirectional switch. A triac is a functionally equivalent to 2 antiparallel connected thyristors. A triac can be turned on with both positive and negative gate current. So correct answer is A, B and C, right? Second, option 2 is the correct option. Next, a voltage source inverter is most suitable in applications where generally we know the VSI, that is voltage source inverters, are used with the inductive load, right? So voltage source inverters are suitable when the load inductor is high but source inductance is low. Fourth option is the correct option. Alright. Whereas in a current source inverter it is ulta. In current source inverter, high value of the source inductance but load inductance required is low. Okay. But in VSI it is source inductance has small value and load inductance is large. Which of the following is the function of an RC snubber circuit connected in parallel to an SCR? Strictly speaking, your RC snubber circuit is used to protect the SCR against high dV/dt or to avoid the false triggering. But if you check the options, here force the commutation of the SCR, that is not true. Limiting the dI/dt through the SCR. No, dI/dt protection we are having inductor na. Third is triggering the SCR. They have given triggering the SCR. Is it true? No. To avoid the false triggering, that is true. Okay, but I think there might be some mistake in the given option, printing mistake. Preventing the over voltages across the SCR. Strictly speaking, RC snubber is used for high dV/dt protection. High dV/dt. But here they have not given the option high dV/dt. But closer option is, as this is also voltage na, so closer option is option 4. Okay, right. In a single phase SCR based full converter with a continuous conduction operating with a firing angle alpha, what is the angle duration of conduction for each pair of SCR in the radians? Each SCR pair conducts for, we know, alpha to pi plus alpha, 2 pi plus alpha, that is pi radian only, right? Correct answer is option 1. Next, which of the following statements is correct in case of multi-loop based closed loop control of DC and AC drives having speed and current feedbacks? This is a multi-loop system where in this speed control we are having the 2 loops. One is the outer loop, that is a speed control loop. Second one is the inner loop, that is a current control loop. Okay, and on the output of the current control loop, your speed control loop output depends. So therefore here the current control loop is faster than the speed control loop. Okay, right. In a 3-phase bridge inverter operating in the square wave mode, the output voltage waveform contains which harmonics they are asking. If my output voltage is a square wave, 180 degree square wave type of output, then which harmonics are absent? All even harmonics are absent, that means only odd harmonics are present, only odd harmonics. It contains only odd harmonics. Option 4 is the correct option. Next, a step-up chopper delivers an average output voltage of 100 volt from an input supply of 60 volt when operating with a continuous source current. Then what is the operating duty ratio they are asking? They have given step-up chopper. We know in case of step-up chopper, V0 is Vs upon 1 minus D. V0 given is 100 volt. Supply voltage is 60 volt upon 1 minus D. Yes, it is simple question. From this we can find the value of D. all right. It is a 0.4, right, 0.4. So correct option is option 4, all right, yes. Next, a motor load combination operating in motoring mode has the following speed torque characteristic. They have given the motor torque equations and load torque equation, where T is the motor torque and yes, T load is the load torque. The speed of the motor load combination in RPM, what is the steady state speed of the system after exciting it? Means they are asking steady state speed. Yes, steady state speed, we know at steady state, whatever the torque demand by the load, the motor is required to supply that torque, na? So Tm equal to TL. Tm equal to TL. Tm is 0.1 into N minus 10 is equal to TL is 0.25 into N minus 75. All right. So from this we can simplify for N value, and after simplification we will be getting N is equal to 433.3 RPM. 433.3 RPM. All right. So if you check the options, the correct option is option 3. Option 3 is the correct option. All right. Yes, simple. It is, you need to equate only Tm equal to TL. That's it. Next, a 200 volt 1000 RPM 100 ampere separately excited DC motor has an armature resistance of 0.1 ohm. The motor is fed from DC to DC step down chopper. Right, means here we are having the step down chopper which is feeding to the separately excited DC motor. So let me first note the data. We are having SE DC motor. SE DC motor. It is given that VA rated is equal to 200 volt. N rated 1000 RPM. IA rated 100 ampere. Armature winding resistance is 0.1 ohm. It is given that the converter is step down chopper. Input voltage to the step down chopper is 300 volt. What is the duty cycle D? Rated torque means T2 is equal to T rated. And the speed N2 is 500 RPM. Assuming operation with continuous current, field remains unchanged, means phi2 is equal to phi rated. Right? So we need to find the duty cycle D value. So first of all, from the given rated values, let us find the EB rated, right? Back EMF rated value. EB rated. It is VA rated minus IA rated into RA. What is VA rated? 200 minus IA rated is 100 into RA is 0.1. So if it is equal to 190 volt. So EB rated is equal to 190 volt. Right? EB rated is 190 volt. Next, now we know EB is proportional to flux phi into N. Na? In this case, flux phi is constant. So can I write EB is proportional to only N? So therefore I can write EB2 upon EB rated is equal to N2 upon N rated. Right? So from this we can find EB2. Therefore EB2 equal to N2 is 500 upon N rated is 1000 into EB rated is 190. So it is 190 upon 2. Okay. So it is equal to 95 volt. So EB2 is 95 volt. Next, now we know torque is proportional to flux into armature current. All right. Here flux is constant, so torque is proportional to only armature current. So I can write T2 upon T rated is equal to IA2 upon IA rated. Now torque is constant, na? T2 and T rated both are equal. So T2 by T rated is equal to 1. So therefore I can write IA2 is same as that of IA rated, which is equal to 100 ampere. 100 ampere. Now IA2 we have written, EB2 we have written. Can we find VA2? Yes. So VA2 equal to EB2 plus IA2 into RA. EB2 is 95 plus 100 into 0.1. So it is equal to 105 volt, VA2. This is VA2, which is nothing but the output of your chopper. So therefore can I write, this is nothing but V0. So therefore V0 is equal to D into Vs. So 105 is equal to D into what is Vs? 300. So from this we can simplify and we can find the D value. It is 0.35. So duty cycle D value is equal to 0.35. So option 2 is the correct option. All right. So these are the questions related to the power electronics. Thank you.
guys, coming to the analog electronics and basic electronics part, and we can find around 13 questions from this subject. Actually, questions are little bit complicated, but examiner provided detailed hint in the question itself, and for some questions hints are given in the options. If you have a basic idea about the subject, we can solve them very easily without lengthy derivations. But indeed, some questions requires more analysis, but for 1 mark and for this kind of questions in public sector, we cannot spend more time. With only with logic, we can move. See, in this circuit, find the output voltage V0. My dear friends, you remember question number 14. We will talk about this question in future. This is actually the hint for some other question in the paper. Okay. See, in this circuit, find the output voltage V0 for negative feedback. But which one should be considered as a inverting terminal? X is negative or Y positive, or X positive or Y negative. Right. See, assume this is Vx. Assume this is Vx. I am not going to give you the detailed derivation for the invalid case. Case 1, if you take X value as positive, that means positive means non-inverting terminal, and Y value negative, then you will get -1. Output voltage V0, after writing one node equation, you will get -1. But this is not given in the option. So clearly he is saying that this is a negative feedback amplifier, and by assuming one of the terminal as negative terminal, inverting terminal, you will get a sufficient answer that you can find in the option. So I am taking the assumption here, X is equals to this time connected to inverting terminal, negative means this is inverting terminal and this is non-inverting terminal. Y is equals to positive. Y is the non-inverting terminal. And if you observe it carefully, see this is inverting terminal. As this is inverting, see the negative feedback configuration, it looks like a non-inverting amplifier. It looks like a non-inverting amplifier. Then what is output voltage? V0 is equals to whatever may be the drop at Vx, Vx into what is the gain formula for non-inverting amplifier? 1 plus this feedback resistor, generally it may be R2 or RF, whatever, RF by R1, assume like that, 1K by 1K, 1 plus 1K divided by 1K. Now what is a Vx? You can write Vx, you can find Vx by writing just one node equation, Vx minus 2 by 2K plus Vx minus V0 by 1K. I repeat it, Vx minus 2 by 2K plus Vx minus V0 by 1K. Then you will get the relation between Vx and V0. And there you will get Vx is equals to 2V0 minus 2 divided by 3. And if you substitute it here, then you will get the output voltage V0 is equals to, substitute Vx in place of Vx means 2V0 minus 2 by 3, then you will get minus 4 volts. Option 2 is the correct answer, right? Remember this circuit, X is negative terminal, okay? X is a inverting terminal, right? In future, I will talk about this circuit again while solving some other question. Yeah. A MOSFET is biased in common drain configuration, is best suitable for designing a resistance, transconductance, current buffer and voltage buffer. See what is this common drain configuration. We have discussed in class in detail in multi-stage amplifier. Common emitter, common base, common collector. Replace emitter, base, collector with source, gate and drain. Then it will be common source amplifier. This is common gate and common collector is nothing but common drain. Right? What is this? This is common drain. Common drain or common collector act as voltage followers or voltage buffer. So that voltage buffer is a correct answer for this question. Actually, this is purely belongs to the ECE syllabus actually. It's a part of the operational amplifier internal circuit, and it is named as current mirror. There are different kinds of current mirrors. This is a PNP type current mirror, and see this. This is a branch. There is a standard principle for the current mirror. The current can be reflect. Whatever the current passing through this branch, the same current can reflect on the second arm of the circuit. Sir, what can be the current through this? Very simple. Base and collector are short circuited, so that I am assuming this as Ix. This is Ix. Here Ix is nothing but I out. Right, as per the mirror image property, right. See this, whatever the current we are going to find through this branch, that current can reflect at I out. V gamma of, see this 0.7 volts is a drop across diode, and transistor you see anode and cathode. Anode to cathode, again there is a 0.7 volts drop across the junction. Then what is this current? Current I out or Ix, that is equals to 5 minus, this is 0.7 drop, right? This is 0.7 drop, 0.7 minus 0.7, or you write 1.4 divided by, what is the path resistance here? 1 kilo ohms. 1 kilo ohms. Then you will get the load current or output current or Ix is equals to, if you calculate it, you will get 3.6 milliamperes. You please do the simplifications, and 3.6, option 4 is the correct answer. Yes. Coming to this circuit, this is from the feedback, concept of feedback. We have discussed some shortcuts to identify the type of feedback. You see, as per our shortcut that we have discussed in the class, this is a feedback network, right? Connected at input virtually, means indirectly. That is the reason I can write it as series type, and directly output is connected, shunt type. Series shunt type. If you forgot that, you know this is basic voltage control voltage source. See, series type, high input impedance, shunt type, sampling at output means low output impedance, high low, voltage control voltage source. It is from the nodes table number 2, right, in feedback amplifiers. So this is high low amplifier or voltage control voltage source amplifier or series shunt type amplifier. Series and shunt feedback type amplifier, option 4. Option 4. See guys, this is the question number 79. If you see this question, sorry, directly, you will get different ideas. How can I find the whether X is negative or positive? See, if values are changes, again maybe there is a difference in the feedback value. Then how can you recognize whether it is suitable for negative feedback or positive feedback? He is given very clearly, for negative feedback configuration, find X and Y. Already we have done this in the question number 14 by considering X value, same circuit he has given. In the question he has given that it is negative feedback type. There if you take X as positive, you did not get the correct options. You got the correct options for question number 14 by assuming X as negative. So here that question number 14 solution will help us to find the correct answer. So this is a type of 2 marks linked answer question. Generally it is a gate model. So in 79 you cannot find proper data. Actually this data is provided in question number 14, right? Okay, anyways, X is negative and Y is positive. Yeah, actually this is again from FET amplifiers. Actually we have studied the basics of FET as per electrical syllabus, but this is a question from the FET amplifier modeling. But this is a modeling, okay, GM into VGS, conductance into voltage, nothing but current. Even you can use your network fundamentals also. You no need to go for VLSI design or CMOS amplifier design to answer this question. If you observe it properly, you can find something. You see, this is VGS. What is the VGS? He has given between these two, right? What is the VGS? GM into VGS. I mean voltage between this gate and source. This is simply means voltage across this branch. GM into VGS. Here also he has given the same, this is VGS. But what exactly the voltage across this? Current into, what is the VGS? Current into resistance is the voltage. Conductance into voltage is what? Current. So what amount of current is passing through this? GM into VGS amount of current. So that VGS from the first figure is equals to, if you want to convert the second figure into first figure, what kind of modifications has to be done? Right, so VGS is equals to, you see, current GM into VGS into R. GM into VGS into R. Then what should be the R value? 1 by GM. Direct I am writing R is equals to 1 by transconductance. Then both the images or equivalent models can be the same. Okay. What is a time period of oscillator? If you observe it carefully, in this portion you can find something. This is a Schmidt trigger that we have discussed. And you see in multi-vibrators, you please go through our discussions. In multi-vibrators, we have discussed monostable multi-vibrator and stable by using 555 timer. But I have given one table. And I told you so many times important formulas, and I have given the table 1, table 2, table 3. In multi-vibrator you can find table 3. In the table I have given the formulas in a systematic order to memorize time periods for monostable and stable for 555 timer by using 555 timer concept and by using Schmidt trigger with RC network. But there in that notes, even in textbooks, this is simply R. But this is R1, this is R2. Please don't confuse, this is R1, this is R2 actually, that is a standard circuit, should not change the values, but in this equation, values are interchanged. So you need to observe it carefully. What is the formula? Actually options are not given, yes. What is the formula? 2RC TC is equals to, or T is equals to 2 R into C. R into C means time constant of the feedback circuit. Log R1, this is R1 in original circuit. In our notes, you can find the formula like that. R1 plus 2R2 divided by R1. But here R1, R2 are interchanged. That means R2 plus 2R1 divided by R2. So 1 plus 2 times that of R1 by R2. 1 plus 2 times that of R1 by R2. But sir, how can we recognize 1 plus or R1 plus R2 or R2 plus 2R1? No need. If you think smart, in this formula we have 2 into RC. The 2 into RC is given in only one option, that's all. 3 is a correct option. 2 R3 C. R3 into C is a time constant of the circuit into log 1 plus 2 R1 by R2. Now solve this question in class. R, this is also R. So node equation 1, node equation 2. If you write 2 node equations, you will get the relation between V0 and Vs, and you can find -3 as answer. But here question is not about gain. Question is about just Ix. One node equation is sufficient. I assume this is Vx. Vk, whatever you want, right? What is the voltage at this node? 0, by using the concept of virtual short. To find the gain, we have done in class, we need 2 node equations. But now here, we need only 1 node equation. If you find Vx, that's enough. Ix is equals to Vx by 3k. Ix is equals to Vx by 3k. You please do the calculations, but I will write the node equation. This is 0 volts, right? So 0 minus 4 volts divided by 6 kilo ohms plus 0 minus Vx divided by this one, 0 minus Vx by 3 kilo ohms is equals to 0. If you write the node equation like this. From here, you will get the voltage at Vx, I think it is minus 2 volts. Yes, Vx, you please do the calculations. You will get Vx is equals to minus 2 volts. If you know the Vx means 2 volts divided by 3 kilo ohms, then you will get the 0.66 actually, you will get 0.6 exact value 66668 something. You can take it as 0.67. This is about the current, okay, milliamperes. Ix equal to 0.67 milliamperes, option 4. You will get minus 2, okay, you will get Vx equal to minus 2, so you will get minus 0.67 milliamperes. Minus 0.67 is given in option 1, because you see I wrote minus 2 volts, right, minus negative voltage by some resistance, current is negative, that's it. 1 is the correct option. A bipolar junction is, it is not a charge coupled device. You see, we have discussed about basic idea of diode, transistor, FET, MOSFET and op-amp in one table, and how they are behaving and what is the switching response. Two kinds of things we have discussed. Actually BJT is a current controlled device, because base current is controlling the collector current, and FET and MOSFET, voltage controlled current source type, right, but transistor is a current controlled current source, or we can say simply it is a current controlled device, right. So current controlled device. See what is the small signal gain of the circuit given below. Same, after small signal amplifiers using transistor, we have discussed the comparisons of transistor amplifier and MOSFET and JFET. Even it can be JFET also, formula is same. But we are actually not deriving this kind of relations even in class also. We are just trying to learn these kind of things without any derivation. Actually you see this look like, you remove this and replace the MOSFET with the transistor, common emitter amplifier using potential divider bias without bypass capacitor, with bypass, without bypass, like that we have discussed. With bypass minus Gm into Rc, but without bypass what is the gain? Voltage gain is equals to minus Rc by Re. In case of transistor, collector resistor, emitter resistor, okay? కానీ ఇది ట్రాన్సిస్టర్ కాదు, మాస్ఫెట్. కలెక్టర్ ప్లేస్లో ఏముంది? దిస్ ఈజ్ ద సోర్స్, దిస్ ఈజ్ ద డ్రైన్. అంటే కలెక్టర్ రెసిస్టర్ ప్లేస్లో డ్రైన్ రెసిస్టెన్స్ ఉంటుంది, ఆర్డి బై ఆర్ఎస్, దిస్ వన్ బై దిస్ వన్. సో మైనస్ 5K బై 5 kilo of course by 1K. So simply this is minus 5. Okay guys, these are the questions from analog electronics. Right guys, one question is missing here. Yes, this one. This is a unique circuit, you know. If you find the magnitude, you will get it as 1. After finding magnitude plot and Bode plot. Magnitude plot and frequency plot, by using the Bode plot concept, you will get magnitude is equals to 1. Of course, here we no need to talk about the phase. It is going to provide the phase of -180 to 0, but as per the options, see the options, high pass, band pass, all pass options are given like that. So as the magnitude is 1, irrespective of the frequency of the waveform, it is not going to amplify any signal frequency and not going to attenuate any signal frequency. It can pass every frequency. In that case, we can call it as all pass filter, but actually all pass filter circuit diagram is unique, you know that. We can, by look at the circuit diagram, we can recognize it. So this is a all pass filter.
హాయ్ ఫ్రెండ్స్, ఎలక్ట్రోమాగ్నెటిక్ థియరీలో మొత్తం 9 క్వశ్చన్స్ అడిగాడు. దాంట్లో జనరల్గా అయితే మనం ప్రీవియస్ క్వశ్చన్స్ చూస్తే కాన్సెప్షువల్ క్వశ్చన్, ఫార్ములా బేస్డ్ క్వశ్చన్స్ ఉంటాయి. కానీ ఈసారి మాత్రం కొద్దిగా అనాలిసిస్ ఓరియంటెడ్ క్వశ్చన్స్ అడిగాడు. ఓకే, వాటిని చూద్దాం మనం ఇప్పుడు. ఇది డైరెక్ట్ ఫార్ములా బేస్డ్ క్వశ్చన్. కన్సిడర్ ఇన్ఫైనైట్ యూనిఫామ్ లైన్ ఛార్జ్ ఆఫ్ 5 nanocoulomb per meter along the positive x-axis in the free space. Calculate the electric field at a distance of 2 meters from the line charge. ఓకే, మనం చిన్న కోఆర్డినేట్ సిస్టమ్ డ్రా, రిఫరెన్స్ కోసం ఒక కోఆర్డినేట్ సిస్టమ్ డ్రా చేసుకోవాలి. ఇక్కడ ఇది ఫార్ములా బేస్డ్ డైరెక్ట్లీ. ఓకేనా, కోఆర్డినేట్ సిస్టమ్ డ్రా చేసుకోండి. ఇలాగా ఎక్కడ ఉంది ఇది? ఇన్ఫైనైట్ లైన్ ఛార్జ్ ఎక్స్ యాక్సిస్ పైన. ఇది ఎక్స్, వై, జెడ్. సో ఇన్ఫైనైట్ లైన్ ఛార్జ్ అనేది ఇక్కడ ఉంది. దానిపైన ఎంత ఛార్జ్ ఉంది? 5 nanocoulomb per meter. ఎక్కడ అడుగుతున్నాడు? ఆన్ జెడ్ యాక్సిస్ పైన. ఎక్కడ? 2 meters దగ్గర, అంటే ఇక్కడ 0,0,2. ఓకేనా, ఫైన్. సో ఎలక్ట్రిక్ ఫీల్డ్ ఏంటండి? E ఈజ్ ఈక్వల్ టు ఎలక్ట్రిక్ ఫీల్డ్ డ్యూ టు ఇన్ఫైనైట్ యూనిఫామ్ లైన్ ఛార్జ్ ఈస్ ρl బై 2π ε0 ρ ఇంటూ ρ క్యాప్. ε0 ఎందుకండి? ఇక్కడ ఫ్రీ స్పేస్ అని మెన్షన్ చేశాడు కాబట్టి. ఓకేనా, ఈ ఫార్ములా వాడాలండి. ఓకే, ఇప్పుడు మనం యూనిట్ వెక్టార్ ఎలా రాయొచ్చు? వెక్టార్ బై ఇట్స్ మ్యాగ్నిట్యూడ్ అని రాయొచ్చు. అప్పుడు ఏమవుతుంది? ఇది E ఈజ్ ఈక్వల్ టు ρl బై 2π ε0 వెక్టార్ బై ఇట్స్ మ్యాగ్నిట్యూడ్ స్క్వేర్. ఓకేనా, సో ఎలక్ట్రిక్ ఫీల్డ్ E ఈజ్ ఈక్వల్ టు ఛార్జ్ ఎంత అండి? 5 × 10⁻⁻9 డివైడెడ్ బై 2π ఇంటూ 1/36π × 10⁻⁹ ε0 వాల్యూ వెక్టార్ బై ఇట్స్ మ్యాగ్నిట్యూడ్. వెక్టార్ ఎంత? ఇది ఇక్కడ ఈ పాయింట్ ఎంత? 0,0,0 పర్పెండిక్యులర్ వెక్టార్ తీసుకోవాలి మనం. ఓకేనా, సో 0 - 0 0 0 - 2 ఇది 2 డిస్టెన్స్ 2 అండి. ఇది 2 z క్యాప్ డివైడ్ బై దీని మ్యాగ్నిట్యూడ్ 2 హోల్ స్క్వేర్. దీన్ని క్యాలిక్యులేట్ చేయండి. దీన్ని క్యాలిక్యులేట్ చేస్తే ఎంత వస్తుంది అంటే 45 వస్తుందమ్మా. 45 z క్యాప్ వోల్ట్ పర్ మీటర్. ఇది ఫార్ములా బేస్డ్ క్వశ్చన్. ఇది ఆప్షన్ ఏ, క్వశ్చన్ 1, ఆప్షన్ 1 ఇస్ ఆన్సర్. నెక్స్ట్ క్వశ్చన్ చూద్దాం. ఇది ఇన్ఫైనైట్ లైన్ కరెంట్ గురించి అడిగింది. ప్రీవియస్ క్వశ్చన్ ఏమో ఇన్ఫైనైట్ లైన్ ఛార్జ్ గురించి, ఇక్కడ ఇన్ఫైనైట్ లైన్ కరెంట్ గురించి. ఇది కూడా డైరెక్ట్ ఫార్ములా బేస్డ్ క్వశ్చన్. ఓకేనా, దీనికి కూడా మనం ఒక చిన్న డయాగ్రామ్ డ్రా చేసుకోవాలి. డ్రా చేసుకుంటేనే మనకు క్వశ్చన్ అర్థమవుతుంది. ఓకేనా? ఇప్పుడు ఏంది ఇక్కడ ఇది ఇన్ఫైనైట్ లాంగ్ కరెంట్ ఫిలమెంట్ క్యారింగ్ 28.1 ఆంపియర్ ఇన్ ద పాజిటివ్ జెడ్ డైరెక్షన్ మీద ఉన్నది. నేను కోఆర్డినేట్ సిస్టమ్ ఇట్లా డ్రా చేసుకుంటా. ఇది ఎక్స్ యాక్సిస్, ఇది వై యాక్సిస్, ఇది జెడ్ యాక్సిస్. ఇక్కడ ఇన్ఫైనైట్ లైన్ కరెంట్ ఉందండి. దీంట్లో కరెంట్ ఎంత పోతుంది? 28.1 ఆంపియర్ కరెంట్ ఫ్లో అవుతుంది. ఓకేనా? అయితే క్వశ్చన్ ఏంది, ఎక్కడ అడుగుతున్నాడు మ్యాగ్నెటిక్ ఫీల్డ్? √20, 0,4 అంటే ఇది ఎక్కడ? ఇది ఎక్స్ జెడ్ ప్లేన్. ఎక్స్ జెడ్ ప్లేన్ అంటే ఇక్కడ అడుగుతున్నాడు. ఎంత అమ్మా ఇది? √20, 0,4. మనకు దీని మీద పర్పెండిక్యులర్ కావాలి. ఫార్ములా ఏంటండి? వాట్ ఇస్ ద ఫార్ములా? జస్ట్ దీని ఫార్ములా ఏంటంటే హెచ్ ఈజ్ ఈక్వల్ టు ఐ బై 2π రో ఇంటూ ఫై క్యాప్. ఇది ఫార్ములా. రో అనేది అక్కడ పర్పెండిక్యులర్ డిస్టెన్స్. ఓకేనా? ఫైన్. దీన్ని ఎలా రాయొచ్చు? ఇది దట్ ఈస్ ద మ్యాగ్నెటిక్ ఫీల్డ్ డైరెక్షన్. మ్యాగ్నెటిక్ ఫీల్డ్ ఎలా డైరెక్షన్ రాయొచ్చు? మ్యాగ్నెటిక్ ఫీల్డ్ డైరెక్షన్ ఈస్ కరెంట్ డైరెక్షన్ క్రాస్ యూనిట్ వెక్టార్. కరెంట్ డైరెక్షన్ జెడ్ క్యాప్ క్రాస్ యూనిట్ వెక్టార్ ఈస్ రో క్యాప్. ఇది యూనిట్ వెక్టార్. దాన్ని ఎలా రాయొచ్చు? వెక్టార్ బై ఇట్స్ మ్యాగ్నిట్యూడ్ క్యాప్, మ్యాగ్నిట్యూడ్ అని రాయొచ్చు. ఓకే, సో హెచ్ వెక్టార్ ఈజ్ ఈక్వల్ టు ఐ బై 2π రో ఇంటూ వెక్టార్ బై ఇట్స్ మ్యాగ్నిట్యూడ్. సో హెచ్ వెక్టార్ ఏమవుతుంది? ఐ ఈజ్ ఈక్వల్ టు 2π ఇంటూ జెడ్ క్యాప్ క్రాస్ వెక్టార్ బై ఇట్స్ మ్యాగ్నిట్యూడ్ స్క్వేర్. ఈ ఫార్ములా వాడాలండి. ఈ ఫార్ములా వాడితే ఎంత వస్తుంది అంటే 1 వై క్యాప్ ఆంపియర్ పర్ మీటర్ వస్తుంది. ఓకే, ఇంకో విషయం ఏంటంటే ఇక్కడ గమనించాల్సింది, మనకి ఎక్కడ కావాలి ఇది? √20, 0,4 కదా. మనకు పర్పెండిక్యులర్ ఎక్కడ కావాలి? ఇది ఈ లైన్ పైన జెడ్ అనేది వేరీ అవుతుంది. ఎక్స్ వై ఫిక్స్ అండి. సో 0, జెడ్ అమ్మ. మనకు పర్పెండిక్యులర్ డిస్టెన్స్ వెక్టర్ కావాలి ఇక్కడ నుంచి ఇక్కడికి. అంటే ఇది 4 చేసుకోవాలి. ఓకేనా? సో పర్పెండిక్యులర్ డిస్టెన్స్ వెక్టర్ ఏమవుతుంది? ఒక్క నిమిషం. Just a second. ఓకే ఫ్రెండ్స్, స్మాల్ టెక్నికల్ ఎర్రర్. అయితే ఇది పర్పెండిక్యులర్ డిస్టెన్స్ అండి. ఇక్కడ మనకు పర్పెండిక్యులర్ డిస్టెన్స్ వస్తుంది. వచ్చిన తర్వాత ఏం చేయాలి? ఫార్ములా వాడాలి మనం ఇక్కడ. ఐ విల్ టర్న్ ద పేజ్. ఫార్ములా ఏంటండి? హెచ్ ఇది ఈక్వల్ టు ఐ బై ఐ ఇంత తీయడమా? కరెంట్ ఎంత? 28.1. 28.1 ఆంపియర్ డివైడెడ్ బై 2π ఇంటూ జెడ్ క్యాప్ క్రాస్ వెక్టార్ ఏమవుతుంది చెప్పండి? √20 మైనస్ 0, 0 మైనస్ 0, 4 మైనస్ 4. ఓకేనా? మిగిలేది ఏంది? √20. √20 ఎక్స్ క్యాప్ అండి, √20 ఎక్స్ క్యాప్ అండి డివైడెడ్ బై √20 స్క్వేర్ అమ్మ. ఓకేనా? దీన్ని క్యాలిక్యులేషన్ చేయండి. ఇప్పుడు జెడ్ క్రాస్ ఎక్స్ అంటే వై క్యాప్. ఓకేనా? సో ఇది 28.1 ఇంటూ ఈ √20 క్యాన్సిల్ అయిన తర్వాత ఇక్కడ వై క్యాప్ డివైడెడ్ బై 2π డివైడెడ్ బై √20 అండి. ఓకేనా? సో చెక్అవుట్ చేయండి. ఆన్సర్ ఎంత వస్తుంది అంటే 1 వై క్యాప్ వస్తుంది. హెచ్ ఇది ఈక్వల్ టు 1 వై క్యాప్ ఆంపియర్ పర్ మీటర్. ఇది సెకండ్ క్వశ్చన్. ఫస్ట్ క్వశ్చన్ ఏమో ఇన్ఫైనైట్ లైన్ చార్జ్, సెకండ్ క్వశ్చన్ ఏమో ఇన్ఫైనైట్ లైన్ కరెంట్. థర్డ్ క్వశ్చన్ చూద్దాం ఇప్పుడు. థర్డ్ క్వశ్చన్ చూడండి, కొద్దిగా విజువలైజేషన్ కావాలి దీనికి. ఓకేనా? ఇక్కడ 3 షీట్ ఛార్జీలు ఇచ్చిండి. అవి ఎక్కడున్నాయి? ఒక చిన్న రఫ్ డయాగ్రామ్ డ్రా చేసుకుందాం. అన్నిటికీ ఒక చిన్న డయాగ్రామ్ డ్రా చేస్తేనే మనకి క్వశ్చన్ అర్థమవుతుంది. ఒక కోఆర్డినేట్ సిస్టమ్ తీసుకోండి రిఫరెన్స్గా. ఇది ఎక్స్ యాక్సిస్, వై యాక్సిస్, జెడ్ యాక్సిస్. ఇది -y -z సారీ. ఇన్ఫైనైట్ షీట్ ఛార్జ్ ఎక్కడ ఉందమ్మా? ఇది ఫస్ట్ షీట్ ఛార్జ్ ఏమో z ఈజ్ ఈక్వల్ టు -2 దగ్గర, అంటే ఇక్కడ ఉంది. ఎంత దీనిపైన ఛార్జ్? 3 నానో కూలం, 3 నానో కూలం పర్ మీటర్ స్క్వేర్. ఓకే, బాగుంది. సెకండ్ ఇన్ఫైనైట్ షీట్ ఎక్కడ ఉందండి? z ఈజ్ ఈక్వల్ టు 0.5 దగ్గర, అంటే ఇంకో ఇక్కడ సమ్వేర్ హియర్. ఎంత దానిపైన ఛార్జ్? 6 నానో కూలం పర్ మీటర్ స్క్వేర్. ఓకే, బాగుంది. మూడో ఛార్జ్ ఎక్కడ ఉందండి? మూడో ఇన్ఫైనైట్ షీట్ ఛార్జ్ z ఈజ్ ఈక్వల్ టు 4 మీటర్స్ దగ్గర. ఓకే, బాగుంది. ఇదంత ఇది -8 నానో కూలం పర్ మీటర్ స్క్వేర్. బాగుంది. అయితే క్వశ్చన్ ఏంది? ఏం అడుగుతున్నాడు? ఎలక్ట్రిక్ ఫీల్డ్ ఎక్కడంట? 2, 5, -5 అన్నాడండి. ఈ విషయం గమనించాలి మనం ఇక్కడ. -5 అంటే ఏంది? అటువైపు, +5 అంటే ఇటువైపు. అటువైపు అంటే మనకు తెలుసు ఇన్ఫైనైట్ షీట్ ఛార్జ్ ఉందనుకోండి, ఎలక్ట్రిక్ ఫీల్డ్ ఉంటుంది నార్మల్లీ అవుట్వర్డ్స్. అంటే మనం ఇటు సైడ్ తీసుకున్నాం అనుకోండి పాయింట్, ఎలక్ట్రిక్ ఫీల్డ్ అటు సైడ్ ఉంటుంది. అటు సైడ్ అంటే ఏ సైడ్? నెగిటివ్ జెడ్ సైడ్. నెగిటివ్ జెడ్ అంటే ఒకసారి చూడండి ఆప్షన్స్లో, నెగిటివ్ జెడ్తో డైరెక్ట్లీ ఆన్సర్ చేయొచ్చా? లేదు. నెగిటివ్ జెడ్ మీద 2 ఉన్నాయి, మనం ఆన్సర్ చేయాల్సింది. ఓకే, చేద్దాం. చలో, ఇప్పుడు మనం ఇక్కడ సూపర్ పొజిషన్ ప్రిన్సిపల్ వాడాలండి. ఫార్ములా ఏందమ్మా? ρs బై 2ε0 మైనస్ జెడ్ క్యాప్ అండి. ఓకేనా? ఇది టోటల్ ఛార్జ్ తీసుకోవాలి. ఫైన్. సో ఇప్పుడు 1/2ε0 ఇంటూ -z క్యాప్. బాగుంది. ఈ టోటల్ ఛార్జ్ ఎంత అండి? ఇది 3 నానో ప్లస్ 6 నానో మైనస్ 8 నానో అమ్మ. 8 నానో ఇంటూ 10⁻⁻⁹ నానో ఉన్నది కాబట్టి -9. ఇక్కడ మిగిలేదు ఎంత అండి? ఇక్కడ 1 మిగులుతుంది. ఇదంతా 1 అవుతుంది. ఓకేనా? సో ఇక్కడ ఇది పైన తీసుకొచ్చిన తర్వాత దీని వాల్యూ ఎంత అవుతుంది ఒకసారి చూడండి. ఇది ఎంత అమ్మా? ఇది 36 π ఇంటూ 10⁻⁹ ఇంటూ 10⁻⁻9 డివైడ్ బై 2 ఇంటూ -z క్యాప్. ఓకే, 18π. 18π అంటే అప్రాక్సిమేట్గా 56 ఇది వస్తుందమ్మా ఇది. ఓకేనా? సో -56.5 జెడ్ క్యాప్ వోల్ట్ పర్ మీటర్. అది సంగతి. ఓకేనా? నెక్స్ట్ క్వశ్చన్ ఇది చూడండి. ఇది జనరల్గా గేట్ క్లాస్లో చేపిస్తాం ఈ క్వశ్చన్. ఓకే, ఇది కొద్దిగా అనాలిసిస్ చేయాల్సిందే. క్వశ్చన్ పేపర్ అంత టఫ్గా లేదు, కొద్దిగా అనాలిసిస్ ఉంది. జనరల్గా ఇట్లా అనాలిసిస్ ఓరియంటెడ్ క్వశ్చన్స్ ఎప్పుడు అడగలేదు. డైరెక్ట్ ఫార్ములా బేస్డ్, కాన్సెప్ట్ బేస్డ్ క్వశ్చన్స్ అడుగుతాడు. కానీ ఫస్ట్ టైం వెయిటేజ్ ఎక్కువ ఇచ్చిండు, దాంతోపాటు కొద్దిగా అనాలిసిస్ ఉన్న క్వశ్చన్స్ ఉన్నాయి. ఇప్పుడు మనం ఏం చేద్దామంటే దీన్ని టాప్ వ్యూ డ్రా చేద్దాం. ఓకేనా? ఏమంటున్నాడు క్వశ్చన్ చదవండి ఒకసారి. క్యాలిక్యులేట్ ద మ్యాగ్నెటిక్ ఫీల్డ్ ఇంటెన్సిటీ హెచ్ ఎట్ 0.4, 0.3, 0 డ్యూ టు 8 amperes ఫిలమెంటరీ కరెంట్ డైరెక్టెడ్ ఫ్రమ్ అవుట్వర్డ్ ఫ్రమ్ ఆరిజిన్, బయట నుంచి లోపలికి, టు ఇన్ఫైనైట్లీ లాంగ్ పాజిటివ్ ఎక్స్ యాక్సిస్. ఓకే, ఇన్వర్డ్ ఫ్రమ్ ద ఇన్ఫినిటీ టు ద ఆరిజిన్. ఓకే, ఉన్నది ఎక్స్ప్లెయిన్ చేసిండు. అయితే క్వశ్చన్ ఏంది అడుగుతున్నాడు? క్వశ్చన్ ఏంది? మ్యాగ్నెటిక్ ఫీల్డ్ ఫైండ్ అవుట్ చేయాలి. ఏడమ్మా? 0.4, 3, 0.3, 0 దగ్గర. నేను ఏం చేస్తాను అంటే దీన్ని టాప్ వ్యూ డ్రా చేస్తాను. ఓకేనా? చలో, ఇక్కడ చూడాలి. టాప్ వ్యూ డ్రా చేద్దాం. ఇది ఎక్స్ యాక్సిస్ అండి, ఇది వై యాక్సిస్. కరెంట్ ఫ్లో ఇట్లా ఉందో ఒకసారి చూడండి. వై యాక్సిస్కి ఇట్లా, ఎక్స్కి ఇట్లా. ఇది 8 ఆంపియర్స్, ఇది 8 ఆంపియర్స్. మనకి ఎక్కడ కావాలి మ్యాగ్నెటిక్ ఫీల్డ్ 0.4, 0.3, 0 దగ్గర. అంటే 0.4 అంటే ఇంకో గీడ, గిది 0.4, గిదేమో 0.3. మనకి ఇక్కడ కావాలి. బాగుంది. ఇప్పుడు ఇది ఎంత అవుతుంది చెప్పారు? ఇది 4, ఇది 3, ఇది పాపులర్ నెంబర్ కదా, ఇది ట్రయాంగిల్ అయింది 0.5 అవుతుంది. మనకి ఈడ మ్యాగ్నెటిక్ ఫీల్డ్ కావాలి. అంటే ఆడ మ్యాగ్నెటిక్ ఫీల్డ్ ఏమైతుంది? డ్యూ టు దిస్ వన్. మ్యాగ్నెటిక్ ఫీల్డ్ డ్యూ టు ఫైనైట్ లెంత్ కండక్టర్ ఫార్ములా వాడాలి. ఓకేనా? ఫైన్. ఇక్కడ చూడాలి కొద్దిగా అనాలిసిస్ ఉంటుంది. ఇది H1 ఈజ్ ఈక్వల్ టు ఇంకో విషయం అండి, మ్యాగ్నెటిక్ ఫీల్డ్ డైరెక్షన్తో డైరెక్ట్ డిసైడ్ చేయొచ్చా? ఇప్పుడు మీరు ఇట్లా కరెంట్ ఫ్లో డైరెక్షన్లో తంబు పెట్టండి, ఫింగర్స్ మ్యాగ్నెటిక్ ఫీల్డ్ డైరెక్షన్ చూపిస్తుంది. ఇది ఎక్స్, ఇది వై, బయట సైడ్ మ్యాగ్నెటిక్ ఫీల్డ్. అంటే బయట సైడ్ ఎయిట్ సైడ్ జెడ్ డైరెక్షన్లో ఉంటుంది. అంటే ఒకసారి పైన వెనకకు పోయి చూడాలి, జెడ్ డైరెక్షన్ ఏది ఉన్నది? అరే ఆప్షన్ 1, ఆప్షన్ 3 జెడ్ డైరెక్షన్లో ఉన్నది. తప్పేలా లేదు, ఆన్సర్ చేయాల్సిందే. ఓకే ఫైన్. ఇక్కడ చూడాలి, ఇది H1 ఏమవుతుంది? ఇది 8/4π పర్పెండిక్యులర్ డిస్టెన్స్. గీ నుంచి గీడికి ఎంత డిస్టెన్స్? 0.4. ఓకే బాగుంది. sin α1 అవునా కదా? sin α1 + sin α2 ఫార్ములా ఇది. అంటే ఇక్కడ నిలబడి దీని కార్నర్ చూడాలి. దీని కార్నర్ చూస్తే 90 degrees వస్తుంది, అంటే 1. ఇక్కడ చూస్తే ఏమొస్తుంది? ఈ యాంగిల్ అంటే సైన్ ఆఫ్ దిస్ యాంగిల్ ఈస్ హౌ మచ్? ఆపోజిట్ బై హైపోటెన్యూస్. అంటే 0.3/0.5 అంటే 3/5. ఏ డైరెక్షన్లో ఉందండి? జెడ్ డైరెక్షన్లో. ఓకే. H2 చూడాలి. H2 ఏమవుతుందండి? ఇక్కడ కూడా 8 ఆంపియర్స్ డివైడెడ్ బై 4π ఇంటూ పర్పెండిక్యులర్ డిస్టెన్స్. ఎంత? ఈ నుంచి ఇడికి 0.3. ఓకే బాగుంది. నేను ఇక్కడ నిలబడి దీని కార్నర్ చూడాలి. కార్నర్ చూసి ఎంత వస్తుంది? యాంగిల్ 90 degrees. సైన్ ఆఫ్ 90 ఈస్ 1. ఓకే. ఇది ఆపోజిట్ బై హైపోటెన్యూస్. అంటే 0.4/5 అంటే 4/5 ఈ జెడ్ క్యాప్. ఈ రెండింటిని యాడ్ చేయాలి. సో హెచ్ టోటల్ ఈజ్ ఈక్వల్ టు H1 + H2 అండి. ఇవాల్యుయేట్ చేయరు, నేను చేసిన. ఎంత వచ్చింది ఇది ఇవాల్యుయేట్ చేస్తే? జస్ట్ క్యాలిక్యులేషన్ అది. 6.37 జెడ్ క్యాప్ వస్తుందండి. 6.37 జెడ్ క్యాప్ ఆంపియర్ పర్ మీటర్. ఓకేనా? పెద్ద విషయం లేదు దాంట్లో, జస్ట్ క్యాలిక్యులేట్ చేయాలి. ఓకే బాగుంది. నెక్స్ట్ క్వశ్చన్ చూడండి. ఇప్పుడు ఇది కాంపోజిట్ కెపాసిటర్ అండి. డిఫరెంట్ మెటీరియల్స్ 3 లేయర్లో పెట్టిండు. దీనికి ఈక్వలెంట్ కెపాసిటర్ అడుగుతున్నాడు. పర్ యూనిట్ ఏరియా. క్వశ్చన్ చదవండి. ఏ ప్యారలల్ ప్లేట్ కెపాసిటర్ ఈజ్ మేడ్ విత్ ద 3 డైఎలక్ట్రిక్స్ ప్లేస్డ్ బిట్వీన్ ద 2 మెటాలిక్ ఎలక్ట్రోడ్స్. ఓకే. థిక్నెస్ ఆఫ్ మెటీరియల్ M1, M2, M3, D1, D2, D3 దాని లెంత్ ఇచ్చిండు. ఓకేనా? దాంట్లో ఉన్న డైఎలక్ట్రిక్ ఇచ్చిండు. ఒక విషయం ఏంటంటే ఇట్లా పెట్టారనుకోండి, వీటన్నిటికీ ఏరియా సేమ్ ఉంటుంది. అంటే అవి సిరీస్లో ఉన్నట్టు. ఓకే. అంటే మనం దీని ఈక్వలెంట్ డయాగ్రామ్ ఎట్లా డ్రా చేయొచ్చు? ఈ కెపాసిటర్లు అనుకుంటే ఇది 1, ఇది 2వ కెపాసిటర్, ఇది 3వ కెపాసిటర్, ఇది C1, ఇది C2, ఇది C3. కెపాసిటర్లు సిరీస్లో ఉన్నప్పుడు ఏమవుతుంది? రిజల్టెంట్ 1/C ఈక్వలెంట్. ఇవన్నీ సర్క్యూట్ థియరీ చదువుకునే. 1/C1 + 1/C2 + 1/C3. బాగుంది. ఇప్పుడు 1/C ఈక్వలెంట్ ఏమవుతుందండి? ఇది ఈక్వల్ టు 1/C1 ఏంది? ε1 × A/D1 అండి, ప్లస్ 1/ε2 × A2 డివైడెడ్ బై D2 అండి, 1/ε3 × A3 డివైడెడ్ బై D3. సారీ, ఇప్పుడు ఒక విషయం గమనించాలి. ఇక్కడ ఇవి ప్యారలల్ కనెక్షన్ కదా, ఇవన్నిటి ఏరియాస్ సేమ్ అండి. అవునా కాదా? ఎస్, వీటన్నిటి ఏరియాస్ దీనికున్న ఏరియానే దీనికున్న అన్నిటికీ ఏరియాస్ సేమ్ ఉన్నది. అంటే ఏ. ఓకేనా? ఫైన్. ఇంకో విషయం ఏంటంటే పర్ యూనిట్ ఏరియా అడుగుతున్నాడు క్వశ్చన్. అంటే అన్నిటినీ 1 చేసేయండి పర్ యూనిట్ ఏరియా. లేకపోతే ఇది సి ఈక్వలెంట్ తీసుకురండి. ఇక్కడ సి ఈక్వలెంట్ డివైడ్ బై ఏరియా తీసుకొస్తే ఏమొస్తుంది? దీన్ని రివర్స్ చేయండి ఉల్టా. D1/ε1 ప్లస్ D2/ε2 ప్లస్ D3/ε3. ఇది ఇన్వర్స్ అవుతుందండి. గది సంగతి. కెపాసిటర్స్ పర్ యూనిట్ ఏరియా. ఇప్పుడు ఆప్షన్స్ కూడా ఇచ్చిండు మనకు. ఏందమ్మా ఇది ఆప్షన్? ఆప్షన్ 3 ఇస్ ఆన్సర్. ఓకే బాగుంది. నెక్స్ట్ క్వశ్చన్. ఇదేంది? ఇది కోయాక్సిల్ కేబుల్ మీద అడిగిండు. ఇక్కడ ఒక చిక్కు వచ్చి పడ్డది. ఏంది అది? ఇది మన క్యాలిక్యులేటర్ లేకుంటే చేయలేము ఇది. ఎందుకంటే ఒకసారి చూడండి ఏమడుగుతున్నాడు. ఇది కన్సిడర్ ద కోయాక్సిల్ కేబుల్ హ్యావింగ్ ఏ ఇన్నర్ రేడియస్. ఇది ఓకే, ఇది ఇన్నర్ రేడియస్. ఇది అవుటర్ రేడియస్. ఓకే. filled with the dielectric material having a relative permeability 50 అంట. The self inductance will be per unit meter అంటున్నాడు. ఇప్పుడు కోయాక్సిల్ కేబుల్ ఇండక్టెన్స్ ఫార్ములా ఏందండి? L is equal to mu L by 2 pi natural log of B by A. అయితే అప్రాక్సిమేషన్ అని ఏమైనా చేసి ఇప్పుడు న్యాచురల్ లాగ్ చేయాలంటే క్యాలిక్యులేటర్ కావాల్సిందే ఖచ్చితంగా. మళ్ళీ ఎట్లా ఇచ్చిండో ఈ క్వశ్చన్ ఆయనకే తెలియాలి. క్వశ్చన్ డిజైన్ చేసినోనికే తెలియాలి. ఎందుకంటే ఆప్షన్స్ కూడా చూస్తే అన్ని దగ్గర ఆప్షన్స్ ఇచ్చిండు. ఏదైనా ఆప్షన్స్ చూసి ఏమైనా ఎలిమినేట్ చేసి ఏమైనా చేద్దామంటే అది కూడా లేదు. మరి ఏం చేద్దామంటారు చెప్పారు? ఓకే, ఇక్కడ చూడాలి. ఇప్పుడు ఏంది ఇది? మ్యూ ఈజ్ ఈక్వల్ టు మ్యూ నాట్ ఇంటూ మ్యూ ఆర్ కదా. సో ఇట్ ఈస్ 4 pi ఇంటూ 10 to the power of -7 ఇంటూ మ్యూ ఆర్. మ్యూ ఆర్ ఎంత అండి? 50. సొల్యూషన్ అయితే ఇస్తా, మరి ఏం చేద్దామని తర్వాత ఆలోచన చేద్దాం. బి బై ఏ, ఇది బి ఏంది? ఇది అవుటర్ రేడియస్ ఎంత అన్నాడు? హావింగ్ ఇన్నర్ రేడియస్, అవుటర్ రేడియస్ 4 mm అంట. 4 mm డివైడెడ్ బై 0.8 అంటే ఎంత అవుతుందండి? ఇది 5 అవుతుంది. ఓకేనా? 4 pi ఇంటూ 10 to the power of -7 ఇంటూ 50 డివైడెడ్ బై 2 pi. ఇంకో విషయం, నేను ఇక్కడ ఈ ఎల్ ఉంది కదా, ఈ ఎల్ ఇటు సైడ్ తీసుకొచ్చిన. సో న్యాచురల్ లాగా 5 అండి. ఫైన్, ఇది క్యాలిక్యులేటర్ వాడాల్సిందే, ఇంకో మాటనే లేదు దీంట్లో. దెర్ ఇస్ నో అదర్ వే. ఎస్, ఫైన్. సో నేను కూడా క్యాలిక్యులేటర్ వాడే చూసిన, చేస్తే ఎంత వచ్చిందంటే 16 μH/m. అది సంగతి. చూడారు ఎంత దగ్గరికి ఇచ్చిండు చూడండి. ఇవి రెండు ఉన్నాయి దగ్గరికి. ప్లీజ్. ఓకే, ఫైన్. ఇంకో క్వశ్చన్ చూడండి. ఇది చేయొచ్చమ్మా, దీంట్లో ఏం లేదు, జస్ట్ ఆల్జీబ్రానే. ఏంది? 4 ఛార్జులు, దే ఆర్ ప్లేస్డ్ ఆన్ ద 4 కార్నర్స్ ఆఫ్ ద స్క్వేర్. ఓకే, చిన్న రఫ్ డయాగ్రామ్ డ్రా చేద్దాం మనం ఇక్కడ, లేకుంటే రిఫరెన్స్ కోసం ఇక్కడే మనం డ్రా చేద్దాం. ఇట్లా తీసుకోండి, ఇది ఎక్స్ యాక్సిస్, ఇది వై యాక్సిస్. ఇక్కడో ఛార్జ్, ఇక్కడో ఛార్జ్, ఇక్కడో ఛార్జ్, ఇక్కడో ఛార్జ్. ఈ పాయింట్ ఎంత? 1, గిది -1, 1, గిది -1, -1, గిది 1, -1. ఓకేనా? ఓకే, బాగుంది. ఇదేందమ్మా? ఇది 1, -1. ఈ ఛార్జెస్ ఎంత అండి? ఛార్జెస్ ఏమి ఇచ్చిండు? 3 microcoulombs, 3 microcoulombs, 3 microcoulombs, 3 microcoulombs, 3 microcoulombs. అయితే విషయం ఏంటంటే ఎలక్ట్రిక్ ఫీల్డ్ ఎక్కడ అడుగుతున్నాడు? 1, 1 దగ్గర అడుగుతున్నాడు. ఓకేనా? ఫైన్. ఇప్పుడు మనం అదంతా క్యాలిక్యులేట్ చేయొద్దు, ఒక్క ఎక్స్ కాంపోనెంట్ వై కాంపోనెంట్ ఏదో చేయాలి. సరేనా? మళ్ళీ ఇంకోటి ఏది పాజిటివ్ ఏది నెగిటివ్ అది కూడా చూడాలి ఆప్షన్స్లో నుంచి, మన టైం బచాన్ వస్తుంది. ఓకే, టైం సేవ్ అవుతుంది. సరే, మన ఎలక్ట్రిక్ ఫీల్డ్ ఎక్కడ అడుగుతున్నాడు? 1, 1 దగ్గర అడుగుతున్నాడు. సూపర్ పొజిషన్ ప్రిన్సిపల్ వాడాలి. ఎలక్ట్రిక్ ఫీల్డ్ ఎక్స్ప్రెషన్ ఏందమ్మా? E ఈజ్ ఈక్వల్ టు డైరెక్ట్ కూలమ్స్ లా Q/4πε. ఇక్కడ జాగ్రత్త వహించాలి. ఏమన్నాడు ఇక్కడ? రిలేటివ్ పర్మిటివిటీ ఇచ్చిండు. జనరల్గా ε0 తీసుకోవద్దు, 2 into ε0 తీసుకోవాలి. ఓకే, సో వెక్టార్ బై ఇట్స్ మ్యాగ్నిట్యూడ్ క్యూబ్ అండి. ఓకే, బాగుంది. దీన్ని క్యాలిక్యులేట్ చేయాలి మనం. XY ప్లేన్లోనేమో 4 ఛార్జీలు ఉన్నాయి. మనం ఇక్కడ 1, 1 దగ్గర ఎలక్ట్రిక్ ఫీల్డ్ ఫైండ్ అవుట్ చేయాలి. దిస్ పాయింట్ మైనస్ దట్ పాయింట్, దిస్ పాయింట్ మైనస్ దట్ పాయింట్, దిస్ పాయింట్ మైనస్ దట్. ఓకేనా? ఫైన్. ఇప్పుడు చూడండి ఎలక్ట్రిక్ ఫీల్డ్ ఏమవుతుందండి? Q/4πε0. ఓకే, Q ఎంత అండి? వీటన్నిటిలో ఛార్జ్ సేమ్ కాబట్టి ఛార్జ్ కామన్ తీయచ్చు. 3 into 10 to the power of -6 డివైడెడ్ బై 4πε0. ఇది ఇక్కడ 2 ఉందండి. ε0 వాల్యూ ఎంత? 1/36 pi into 10 to the power of 9 అండి. 1 - 1 ఇక్కడ నుంచి స్టార్ట్ చేద్దాం. 1 - 1 ఇట్ ఈస్ 2x క్యాప్. 1 - 1 0 అవుతుందండి. 1 - 0 ఇట్ ఈస్ ప్లస్ z క్యాప్. దీని మ్యాగ్నిట్యూడ్ ఎంత అమ్మా? √5 హోల్ క్యూబ్ ప్లస్ 1 - 1 0, 1 - 1 0, 1 - 0 ఇట్ ఈస్ z క్యాప్. దీని మ్యాగ్నిట్యూడ్ 1 క్యూబ్. ఓకే, బాగుంది. ప్లస్ ఇదండి మూడోది. 1 - 1 ఎంత? 2. 1 - -1 2 x క్యాప్ ప్లస్ 1 - 1 ఇది 2 y క్యాప్. 1 - 0 ఇది ప్లస్ z క్యాప్. ఇదంతా √9 హోల్ క్యూబ్ అవుతుంది. అంతేనా? రైట్, చలో. ఇది 1 - 1 ఎంత? 0. 1 - 2 ఇట్ ఈస్ 2. ఇది 2 y క్యాప్. 1 - 0 ఇట్ ఈస్ ప్లస్ y క్యాప్ ఫర్ z క్యాప్. √5 క్యూబ్ అండి. అది సంగతి. ఓకేనా? ఇది క్యాలిక్యులేట్ చేయండి, అన్నీ చేయొద్దు. అన్నీ చేస్తే టైం వేస్ట్ అవుతుంది. మనం ఏం చేయాలంటే ఓన్లీ ఎక్స్ కాంపనెంట్ మీకు ఇది నచ్చింది చేయండి. ఇంకో విషయం ఏంటంటే అన్ని పాజిటివ్ ఉన్నాయి, నెగిటివ్ అనేది రాలేదు అంటే అక్కడ నుంచి ఏమన్నా మనం ఆన్సర్ డిసైడ్ చేయొచ్చా? ఒకసారి చూడరు. లేదు, అన్ని పాజిటివ్ ఉన్నాయంటే దీంట్లో ఉన్నది దీంట్లో ఉన్నది, దేర్ ఈజ్ నో అదర్ ఆప్షన్. ఇప్పుడు మనం ఏం చేయాలి? ఎక్స్ కాంపనెంట్ ఒకదాన్ని క్యాలిక్యులేట్ చేసి చూద్దాం. ఇంకోటి ఏంటంటే ఎక్స్ వై సేమ్ ఉన్నాయి, అక్కడ నుంచి ఏమైనా వస్తుందా? ఇక్కడ కూడా ఎక్స్ వై సేమ్ ఇచ్చిండు, ఎలిమినేషన్ తోటి వస్తలేదు, మనం చేయాల్సిందే ఖచ్చితంగా. ఫైన్, ఇప్పుడు చేద్దాం. ఇప్పుడు ఇది ఏమవుతుంది? ఇది 9, యూ కెన్ టేక్ దిస్ వన్ ఇంటూ 3 into 10 to the power of 9. ఇది ఎంత అండి? ఇది 3 into 9 into 10 to the power of 3 వస్తుందండి, డివైడెడ్ బై 2. ఇది మర్చిపోద్దు, నేను ఓన్లీ ఎక్స్ కాంపనెంటే తీసుకుంటున్నా అమ్మా, ఎక్స్తో డిసైడ్ చేస్తా ఆన్సర్. ఓకేనా? ఇక్కడ ఏమొచ్చింది? ఎక్స్ కాంపనెంట్ 2 డివైడెడ్ బై 5√5. ఓకే, బాగుంది. ఇంకొక ఎక్స్ కాంపనెంట్ ఉంది, ఎంత ఉండండి? ఇది 2 డివైడెడ్ బై 9 into 3 వచ్చింది. ఓకేనా? చలో, ఈ 2 క్యాన్సిల్ అవుతుంది. సో 9 into 3 27, ఇది 27 into 10 to the power of 3 డివైడెడ్ బై 1/√5 ప్లస్ 1/27. ఇది క్యాలిక్యులేట్ చేయండి. క్యాలిక్యులేట్ చేసి ఎంత వస్తుంది అంటే 3.41 వస్తుంది. 3.41 అంటే ఎక్స్ కాంపోనెంట్ 3.41 వచ్చింది. ఎక్స్ కాంపోనెంట్ 3.41 దేంట్లో ఉంది? దీంట్లో ఉంది. అంటే ఆప్షన్ ఇది సంగతి. ఓకే, ఇంకో క్వశ్చన్. ఇది డైరెక్ట్లీ ఫార్ములా బేస్డ్ క్వశ్చన్. దీంట్లో డైరెక్ట్ చేసేయచ్చు. ఏమన్నాడండి? ఛార్జ్ అనేది పాయింట్ ఆరిజిన్ దగ్గర ఉన్నది, ఒక పాయింట్ దగ్గర పొటెన్షియల్ ఇచ్చిండు, అయితే ఛార్జ్ ఎంత అని అడుగుతున్నాడు. ఇంకోటి ఏమన్నాడంటే పొటెన్షియల్ ఈజ్ టేకెన్ ఫ్రమ్ ద ఇన్ఫినిటీ. రిఫరెన్స్ ఎక్కడ? ఇన్ఫినిటీ దగ్గర. ఇన్ఫినిటీ దగ్గర ఎలక్ట్రిక్ ఫీల్డ్ ఏముండదు, వర్క్ డన్ 0, అంటే 0 రిఫరెన్స్ తోటి, అంటే అబ్జల్యూట్ పొటెన్షియల్ ఫైండ్ అవుట్ చేయమంటున్నాడు. ఒక చిన్న డయాగ్రామ్ గీద్దాం. ఇది ఆరిజిన్ దగ్గర 0,0,0. మనకి ఎక్కడ అడుగుతున్నాడు? -2, 3, 1 దగ్గర. ఇక్కడ పొటెన్షియల్ ఎంత అంట? 36 volt. ఓకేనా? ఫార్ములా ఏందండి? Q/4πε0r, ఫ్రీ స్పేస్ అన్నాడు. ఇది ఎంత పొటెన్షియల్ అంట? 36 volt. మనకు కావాల్సింది ఛార్జ్. చలో చేసేరు. ఇక్కడ ఎంత వస్తుంది? 36 into 4π into 1/36π into 10 to the power of 9 into స్క్వేర్ రూట్ ఆఫ్ డిస్టెన్స్ ఎంత దీనికి మధ్యలో? ఇది 4, 9, 1. ఓకే, సో హౌ మచ్ ఈస్ దిస్? 4 into స్క్వేర్ రూట్ ఆఫ్ 14 into 10 to the power of -9. ఎంత వస్తుందండి? 15 నానో కూలమ్స్ వస్తుంది. చెక్ చేయండి, 15 నానో కూలమ్స్ ఈజ్ ఆన్సర్. అది సంగతి. ఆప్షన్ 3 ఈజ్ ఆన్సర్. ఇంకో క్వశ్చన్ చేద్దాం. ఇది లాస్ట్ క్వశ్చన్ అండి. ఇది కూడా అంబిగ్విటీ, సారీ నాట్ అంబిగ్విటీ, దీనికి కూడా క్యాలిక్యులేటర్ కావాల్సింది, ఎందుకంటే న్యాచురల్గా వస్తుంది కదా ఇక్కడ. ఓకే, ఏమడుగుతున్నాడు? కన్సిడర్ ద కోయాక్సిల్ కెపాసిటర్ హ్యావింగ్ ద ఇన్నర్ రేడియస్ ఆఫ్ ఇది అండ్ అవుటర్ రేడియస్ దిస్ వన్, హ్యావింగ్ ఎ లెంత్ కూడా ఇచ్చిండండి. అజ్యూమ్ ద డైఎలక్ట్రిక్ టు బి ఎయిర్. ఓకే, ఎయిర్ డైఎలక్ట్రిక్. కెపాసిటర్ ఏంటండి? కోయాక్సిల్ కేబుల్ 2πε0L బై న్యాచురల్ లాగ్ ఆఫ్ B/A. ఇది సంగతి. ఇప్పుడు న్యాచురల్ లాగ్ వచ్చిన తర్వాత ఏం చేయాలి చెప్పాలి? క్యాలిక్యులేటర్ కావాల్సింది ఖచ్చితంగా. మరి ఎట్లా ఇచ్చిండి ఈ క్వశ్చన్? ఏం చేద్దామంటారు? నేనైతే క్యాలిక్యులేటర్ చూసే చేసిన. దెర్ ఇస్ నో అదర్ వే ఫర్ అస్. న్యాచురల్ లాగ్ వచ్చింది, అప్రాక్సిమేషన్ చేద్దామంటే చూడండి ఆప్షన్స్ ఏమో దగ్గరకి ఇచ్చిండు. ఓకే, ఫైన్. ఇది సబ్స్టిట్యూట్ చేయండి అమ్మా. ఇదంతా ఇది 1/36π into 10 to the power of 9 ఇంటూ లెంత్ కూడా ఇచ్చిండు. ఎంత లెంత్? ఎంత ఇది? లెంత్ ఆఫ్ 0.3048 డివైడ్ బై న్యాచురల్ లాగ్ ఆఫ్ B/A. B ఎంత అండి? అవుటర్ రేడియస్ ఎంత? అవుటర్ రేడియస్ 0.68 డివైడెడ్ బై 0.1045. ఇది న్యాచురల్ లాగ్ ఆఫ్ 6 వస్తుంది. ఆ వాల్యూ మనకు తెలుసా? తెలియదు. మళ్ళీ ఏం చేద్దాం? క్యాలిక్యులేటర్ చూసే చేసిన నేనైతే. దేర్ ఇస్ నో అదర్ వే ఫర్ అస్. క్యాలిక్యులేటర్ తప్పించి ఇంకో మార్గం లేదు. 10 to the power of -12. సో ఇది 2 క్వశ్చన్స్ మాత్రం ఖచ్చితంగా క్యాలిక్యులేటర్ కావాలి. మిగతా క్వశ్చన్స్ మాత్రం మన క్యాలిక్యులేషన్ స్పీడ్ బట్టి ఉంటుంది. కొద్దిగా అనలిటికల్, కొద్దిగా విజువలైజేషన్ కావాల్సిన క్వశ్చన్ ఇది. రెగ్యులర్గా అడే క్వశ్చన్స్ అడగలేదు. నంబర్ ఆఫ్ క్వశ్చన్స్ పెరిగినాయి ఈ ఎగ్జామ్లో. జనరల్గా కాన్సెప్చువల్గా ఫార్ములా బేస్డ్ అడుగుతాడు, కానీ ఈసారి కొద్దిగా అనాలిసిస్ ఓరియంటెడ్, కొద్దిగా విజువలైజేషన్ సంబంధించిన క్వశ్చన్స్ అడిగాడు. ఓకే, హోప్ యూ హ్యాడ్ ఎ గుడ్ డే. థ్యాంక్ యూ. దిస్ ఈజ్ ఆల్ ఫర్ నౌ. అండ్ our colleague friend will going to continue with the other remaining questions. Thank you. Good luck.
Yes, it is a time for the control system questions. Now, observe first question. Here, observe, given the question, here a trans function is given, examiner. Now, this is a trans function. We were discussing nicely in the classroom. Now, trans function, if you observe, this is a S-plane. Here, 1 0 at S equal to +1, 1 pole at S equal to -1. Pole at left side. Pole at left side means the system is stable. The system is stable. And this is one equal distance. Equal distance means it is alpha system. C1 is correct, alpha system is correct, and also stable system. Stable system and alpha system, without touching pen and paper, we can tell the answer B and C. Alpha system as well as B and C. B and C means option. Okay, fourth one is correct answer. Fourth one is correct answer. Now, next one. Examiner was given differential equation. Now, simply apply the Laplace transform both side. Laplace transform both side. Now, 2 dots here. 2 dots means 2s square. S square x of s. Now, plus 6 x of s plus 5. X of s equal to, now 10. Apply the Laplace transform for this one. Apply 1 upon s minus 1 upon s plus 1. Now, what is the trans function now, tell me? X of s equal to, take the LCM. After taking LCM, 1 by s into s plus 1. Now, send this term this side. S square plus 6s plus 5. Now, examiner is asking steady state value. Steady state value. What is the formula for steady state value? Come on, tell me. Steady state value formula. Steady state value formula equal to limit s tends to 0, s into x of s. S going to cancel. Wherever the simple technique here, wherever the s is there, substitute s equal to 0. Wherever this is there, substitute s equal to 0. Substitute s equal to 0. 10 by 2. This is going to cancel. The answer is 10 upon 5. So 2 is perfect answer. 2 is perfect answer here. Yes, this is the correct answer. Next. Okay, one more question. Now the trans function, we were discussing nicely this question in the classroom. You can open your notebook. We have the same question in the classroom also. S plus alpha by s plus beta. For the lead compensator, in control system regular class also you can observe last question of the control system question. Same lead compensator, you can check this paper. Now, in order to act as a lead compensator, lag compensator, alpha and beta should be positive. Alpha and beta should be positive. That is a simple technique. Both positive means first option is given, both are negative, so wrong option without touching pen and paper. And one more technique here, that numerator part alpha should be less than beta value. Alpha should be less than beta value. So which option is having alpha less than beta? This is greater than this one. This is greater than this one. Obviously, by closing your eyes, you can put the option third one. So that is one more question. Without touching pen and paper, we can tell the answer control system. 95% I'll challenge from our classroom ACE Academy. I'll challenge in front of camera, okay? Now from our classroom, we can check the 95% question without touching pen and paper. Now, yes. Next, one more question. It is also simple question. Examiner was given closed loop trans function output. Now, output of the closed loop trans function. What is the trans function of output? Apply the Laplace transform. Apply the Laplace transform means what we will get, come on, tell me, s plus 2. So clearly mentioned closed loop. Closed loop means simple write down closed loop trans function. But examiner is asking what command? Open loop trans function is asking. Shortcut technique. What is the open loop trans function? Yes, open loop trans function shortcut. Simple, this numerator part is there, na? Subtract from the denominator. Now, okay, denominator means s plus 2 minus 1. So 1 upon s plus 1. What is the correct option here? First one is correct answer. Now, closed loop is given, is asking to find the open loop. This is one more question. This is a direct bit. Direct bit. There is no formula is required. Now, in the numerator s is there. Means remove the sign option. In the denominator plus symbol means cos. Denominator minus symbol means cos hyperbolic. So third one, direct formula. There is no chance to put the pen to paper also. Okay, direct with eyes only we can tell the answer. Direct. Simple logic. S means remove these two option. Plus means cos. Minus means cos hyperbolic. Okay, done. Now, 10 question, maximum 7 minutes is enough. One more question. This is a direct bit, integral controller. PD controller, PI controller. This integral control improves the steady state response. Now, do you know or not? Here, simple logic. Lead compensator, okay, PD. In the classroom also, we were discussing nicely. D, last one D na. There also D na. DD. Last one D. So D means this lead will improve the stability. Where about counterpart PI? Stability means transient response will improve. Where about the PI controller improve the steady state response. Steady state response means the best suitable option is option. Third one is correct answer. Integral controller. Where about the derivative controller will improve the stability. Stability means this one wrong option 100%. That is also direct bit from the controllers. Now, okay, fine. Next one. Yes, gain crossover frequency. Many questions we were discussed on this model. Gain crossover frequency. Gain crossover frequency means magnitude at gain crossover frequency should be 1. Now I am writing the magnitude here. Magnitude of this trans function pi upon s e to the power of minus 0.25 product of 1 at omega equal to omega gc. Dear students, modulus of, according to mathematics, mod of exponential signal is 1 only. Mod of exponential signal is 1. If you know that mass formula, this problem is complete. I think controls also not required. Mathematics. Mod of exponential signal is 1. Why? Because cos plus j sine, cos square plus sine square is 1. So this is a pi. In the place of s, you have to substitute omega gc. Omega gc equal to 1. So omega gc equal to what, dear? Come on. Pi radian per second. This is the simplest question. Now direct bit here. Third one, pi. This formula, you should know the mathematics formula, exponential mod equal to 1, then pi by omega gc equal to 1, completed. This is a gain crossover frequency. Now we'll observe one more question here from the control system. Yes, this is something pen and paper is required. Till now almost all 6-7 questions are completed, but without touching pen and paper, with eyes only, okay, now we can tell the answer, but this is something pen and paper is required. Now, simple only, characteristic equation is given. What is the characteristic equation? Come on, response. Characteristic equation is given here. Yes, s power 4, s power 3, RH method, Raut-Hurwitz method, s power 0. Now, 1 coefficient, pi coefficient here, 1, 5, k plus 10. Next one, odd numbers, 3, 6, 0. Come on, reply here. 3 into 5, 15 minus 6, 9. 9 upon 3, 3 only. So out of 4 elements, this element 0 means next above element k plus 10. Now, this element 18 minus this one upon this one. So we'll get minus k plus 4 dear. Check it after simplification. Now this is a k plus 10. Is asking condition for stability. Condition for stability means, here observe, condition for stability. Now condition for stability means, yes, all should have the same sign. Already these two are positive sign. These two compulsory positive. For stability, these two should be compulsory positive. Compulsory positive means for stability, k plus 10 greater than 0, and not only this one, and this should be 0 means inside one minus sign is there. So to generate plus sign, this inside bracket should be minus, and k plus 4 should be less than 0. All people are going to commit the mistake. All people are going to take the k plus 4 greater than 0. No dear. Already outside minus sign is there. To get the plus sign, general mathematics, minus into minus equal to plus, that logic. But in the getting idea in the exam are little bit difficult only. Now minus sign, that is a twist here. Minus sign inside is there. This should be less than 0. Students will take the greater than 0. Bad luck option is also present. So now k greater than minus 10, k greater than minus 10 here, minus 10, and k less than minus 4. So best suitable answer here. Now minus 10 less than k less than minus 4. Yes, now tell me what is the correct option here. Yes, second one is correct answer. That is the second one is correct answer. Only this question till now we touched the pen to paper. Now this is also stability, lengthy question only. Stability is asking. Stability, controllability, observability. Stability means we need required characteristic equation. Yes, in the classroom we were discussing nicely shortcut technique. First of all, regular method is characteristic equation is SI minus A equal to 0. This is a regular method. This is a regular method, but it takes almost 5 minutes time. SI minus A, mathematics, matrices are required. Simple shortcut here, you know very well. Simple shortcut. What is the rows and column of this A matrix? This is A matrix 2 cross 2. So S square, move reverse. This minus become plus 6s. This minus become plus 3. No sir, I want regular method means you can use this formula, find out. Now by using mathematics formula, the roots of this one, minus b plus or minus square root of b square minus 4ac upon 2a. If you find the roots are negative, these roots are negative. What are these characteristic equation roots are negative? Roots are negative. Roots are you're going to get negative. Hence, all are in the left half of S plane, lies in the left half of S plane, left half of S plane. That is the reason why system is stable here. First thing, system is stable here. So stable means we can eliminate what are the wrong options here. Oh, only one option is unstable is given. We can eliminate only one option only as of now. System is stable, stable, 3 options are there. Now controllability. For controllability, what we have to do? For controllability, controllability here, the formula for controllability, MC equal to BAB dear. Find out determinant. Here after finding determinant, what happens here? Det of MC value not equal to 0 we get. So it is also okay controllable, fully controllable it is. Now similarly we need to write the observability. Observability, either observability dear. For observability, what is the formula for observability? Come on, just recall. What is observability formula? M naught equal to C transpose A transpose C transpose. By finding what happens here, by finding det of M naught not equal to 0 dear. So it is also observable. What is the best suitable answer? It is a full positive, full positive. A system which is having stability, controllability, observability. So obviously first one is suitable option. First one is a suitable option. Now, yes, this is the simplest question in the entire control system. This is the simplest question. You can check, okay, you can check your notes also. Direct bit, in the classroom notes also I have given, as it is bit here. They did not change the options also. At least they have changed. Only changes I given A, B, C, D or 1, 2, 3, 4. There. So when the plot is passing through -1 plus A0, the system is marginal stable. When the system passing through -1 plus A0, system is marginal stable. Marginal stable means for marginal stability, gain margin is 0 dB, gain margin is 0 dB, phase margin is 0 degrees. Phase margin is 0 degrees dear. Direct bit. So option 4th one is correct answer. Option 4th one is correct answer. Yes. And one more question also there, 137 question number. That is a common to both network and as well as control system. Both, okay. Now zeta value is given directly. I hope already discussed here. Zeta value, damping ratio. This is the era of my time response chapter. Zeta. That is a directly R by 2 square root of C by L. Check your notes also. That is a 137 question. Already you discussed in the network theory. So zeta also given. That is a damping factor. So dear, these are the questions from the control system. Now, almost all out of 11 questions, only 2 questions you can touch the pen to paper. Remaining all 9 questions with eyes only we can tell the answer. That is the beauty of the, okay, from the classroom question only given. That is from the control system. Very simple. It is not medium also. Simple question from the control system here. I hope, okay. Now you have written very well. So hope for good. All the best. God bless you dear. ఏం చెప్పాలా? ఓకే రైట్.